Hello.
Hello. It's great to be back. How are you feeling,
Yes.
Adrian?
Fine. Finally back.
Oh, I felt that transition. I just nailed the countdown with
Yeah.
the.
Yeah. So how many times you clicked on the volume to get that done that smoothly in the resolution of 30 clicks or something like that. So
So today we're doing a reaction video. It's a new format. Hello, everyone.
hello.
We haven't been streaming for a while because health issues, organizational issues, logistics issues, busy with clients. So as a little teaser, as a little starter, we're having a little Friday stream to get back into the groove. We are having our more regular streams starting next week. So we're sort of going back into normal OTJ schedule. The Thursday one will move slightly. We're experimenting with some new times. And the Wednesday one we'll be having with Brian Finster at 4 p.m. That one's already announced. Bookmark it. And there's going to be a lovely conversation about probably continuous delivery with UIs and front ends, and a lot of engineering culture discussions with Brian. Anything you'd like to add
there will
there?
be a lot of interesting topics to discuss. I think he's looking forward for that one already. Told me, and me too. I'm looking forward for that one as well. But today we have a different topic. Interesting as well, right? So there were several questions tossed towards us about a specific video, actually, and it wasn't really on LinkedIn or something like that. I just heard from many people, hey, what's your opinion about that?
Yeah.
And I took a look at the video. It's about ThePrimeagen interviewing Uncle Bob about TDD and other topics. And I haven't watched the video in its total. I don't know, just some snippets of it, and in those snippets it felt a little bit controversial for me, to be honest, and not what I have expected. But the point is, I already forgot entirely. And,
Okay.
But Dennis then told me that, hey, it's probably a good idea to talk about that as a topic to react to, because he had the same feelings about that. And the idea is to really go through the video today and take a look or stop at some specific points and then talk about that. What actually happens there? What is probably our opinion about that? Do we agree or not? So I'm totally without any opinion here right now, because I don't know what to expect.
For context, ThePrimeagen is one of the biggest growing YouTube channels that you might consider a tech influencer on social media. He used to work for Netflix.
Often combined with Theo, actually.
Yeah, so him and Theo got popular at about the same time. Now Tor from Pirate Software is also getting a lot of traction with YouTube Shorts. And there are notorious tech engineers who have gone solo while streaming, while content creating on YouTube, right? So they have a huge followership. They carry a lot of influence with especially our generation of engineers, the younger generation of engineers, and it's just entertaining in general. Point is, Primeagen and everybody else in sort of that, let's say, US-centric, more craft-oriented, old-school kind of engineers, they're a little bit contrarian towards TDD, a little bit contrarian towards testing, a little bit contrarian towards clean code. And then you have Uncle Bob, who wrote the book. If you don't know who Uncle Bob is, he's been an engineer for like 40, 50 years. One of the signatory members of the Agile Manifesto. That's also something they talk about in the video, which I found interesting. So we'll be reacting to the video where they talk about Agile, TDD, and clean code. And I think that touches on a lot of our topics. So you, the audience, have told us, hey, what do you think about this? And we're about to tell you what we think about it. I'll just close the window because I can hear. If I can hear it, you can hear it. It's needless annoyance.
Actually,
Now it's fixed. Now it's closed. Now I'm ready.
So I wasn't hearing anything, but okay. There. So.
Hi, hello. Also, this is an experiment. This is our very first reaction video. So let's jump in. There's going to be some mistakes. There's going to be some audio issues. There's going to be too much pausing, too little pausing. Let's get messy.
So
let's just start the video. It's a 1 hour video. This is a 2 hour stream. I think the math checks out. Abspielen.
By Uncle Bob, Robert Martin himself. How you doing?
I'm well, thank you.
Why don't you give like a kind of an introduction to who you are, so anyone that doesn't know, they can get to know you.
Oh heavens! Yes, I'm Uncle Bob, or I'm Bob Martin. Some people call me Uncle Bob. I've been a programmer for 50 some odd years. Written all kinds of code in assembly language and C and Fortran and COBOL and C++ and Java. And nowadays I work in Clojure. That's the language I enjoy. You may know me also as the author of Clean Code and a whole bunch of other books over the years. So that's who I am.
You also signed...
Just this is a quick interruption. Every software developer who is a little bit more seasoned is like that. So I have done this and that over that amount of years. I'm guilty myself. And it is a little bit like this is how we define ourselves, right?
Yeah. And I've gotten a lot of feedback over the years, especially in running TDD workshops, TDD lectures. A lot of people don't like TDD the way Uncle Bob presents it, just because of his stage persona. He's a little bit funny, he's a little bit goofy, and a lot of people just don't vibe with that.
Yeah.
He's
and I'm
totally
seeing different to other people like Dave Farley, for example, or even Brian Finster, where they are very serious about those topics.
Yeah, so
and
he has
arguing very hard.
Yes, he's quite argumentative, and he has a little bit of a this is the right way sort of lecturer style, but he doesn't have a super heavy academic background. He's been an engineer his entire life, but it doesn't come off like that. And I just wanted to mention that a lot of people raise objections about that to me personally when I mention Uncle Bob as one of the people who have popularized TDD, but he's not the only person who has done so.
The original Agile Manifesto, 2003, February 13th?
2001, February 2001. Yes, that's true. We were all there together.
Yep.
There were 17
okay,
of
so
us there.
I just have to ask, how did you get to Clojure? Because I did read that article where you talked about Clojure and all that, and I think that's how we had our first introduction, is me reading that article, which I just find Clojure to be such a bizarre language jump from I guess the more like will we call it enterprise Java style programming.
Yeah, so it took a lot of therapy to get to Clojure. Somebody gave me a book recommendation 20 years ago, and the book was The Structure and Interpretation of Computer Programs. An old book, right, out of the 80s. And I got the book. I think I got it on eBay, and it was a secondhand book. I stuck it on my shelf. I didn't read it for a while, and then one day I started just thumbing through it, and the book just captivated me. It was like one of those moments when, like, oh my God, what the hell am I reading here? And
what's the name of the book again? Can you say the name one more time?
The Structure and Interpretation of Computer Programs, which you can get for free nowadays. It's SICP.org, I think.
Okay. I don't think I've ever read that.
Oh, yeah. Well, you can Google it. You can get it for free. You can also see all the old lectures by Abelson and Sussman. They're all online. And then, 1980s guys drawing parentheses on the blackboard. It's very, very fun stuff to do. But the book just catalyzed me. It energized me. I thought, well, this is interesting. And, of course, the language was Lisp, or it was Scheme, right? A Lisp derivative. And I thought, okay, I had for 30 years thought I'm never going to learn Lisp. I don't want to learn Lisp. It sounds like a dumb language. No.
I'm currently on that team, and I'm crossing my 20-year mark, so I'm close.
Okay, so I read that book.
Have you any experience with Lisp?
I programmed, as far as the older languages go, I programmed in Pascal and Turbo Pascal, a little bit of Go, and then I went into the more C-like languages. I never touched Lisp. Oddly enough, I never touched Lisp. Yeah.
I changed my mind. And I thought, okay, I got to get a Lisp. And I just happened to bump into Clojure. I had known Rich Hickey off and on for long years because he used to debate on the C++ news groups back when there were news groups. And I saw his work on Clojure, and I thought, I'm going to get this language. I'm going to diddle around with it. And this was probably...
For the majority of the time, I was thinking that Clojure was actually a JavaScript minifier from Google.
2010. And I just fell in love with the language. It was just wonderful. And I've been
that was Google's Clojure compiler, which was pronounced the same but written differently.
Yeah, and I thought it was the same. So I was thinking how people are programming in that or something like that.
Wow. Okay. Yeah. Well, what is like? Just because I'm fairly kind of stuck in my C-looking language ways. I generally don't. We were having a talk earlier that I think one of the reasons why functional style languages are largely unsuccessful is because their syntax is stupid. Is what I was saying. When I say stupid, I mean that the average person who's had 10 years of programming that looks at functional syntax, they're just like incapable of just even reading it to begin with. It's just so divergent from what is like kind of the zeitgeist of programming.
Yeah.
And so. How was that transition? Because that's clearly where you fell in love with it. Was there like a hard period? Was there a time where you're just like, why am I doing this to myself?
So the syntax of Lisp, and therefore Clojure, is so absurdly simple that there is no syntax barrier to cross. And there's almost no syntax to the language. So the most startling thing when you get into it, the most startling thing is you're asking yourself, where are all the handles? How do I control this language? Where's the class keyword? Where's the type keywords? Where are all these keywords? And the answer to that is there aren't any. And all you really have are a couple of very, very simple gestures, which, by the way, makes the language remarkably expressive. The less syntax, the more semantics, as it turns out.
But isn't it the same with BASIC, actually?
I mean, BASIC, yeah.
BASIC
is something... but BASIC was sort of in the middle. BASIC 6, yes. I programmed BASIC 3, BASIC 6, and VB.NET.
So I was really thinking of the C64 BASIC.
QBasic.
Commodore BASIC and stuff like that. QBasic later on.
QBasic, yeah.
Amiga BASIC.
Yeah, I was too young. I don't remember.
They were exactly like he was describing it, actually.
Yeah.
So,
So I really like the simplicity of functional languages. But I do find myself going to that same experience of like, where are the keywords? Like I would like some keywords. I would like some keywords to declare a particular type of type, rather than having to learn all these like new operators. A lot of times keywords were replaced with certain operators, and then we'll have to learn what the left fold operator was, what the pipe operator was, what this operator was, how a assignment was different from a declaration. So yeah, I did a little bit of Lua, I did a little bit of... Yeah, that's mostly it. And as close as we can get with languages like TypeScript, but that's very far off from functional programming. I didn't do any of the Lisp languages.
Okay. So Kaloyan said Raspberry Lisp was a thing. I think it was used as a tool when I was in college, 97, 200.
Oh yeah, in university I used
Yeah.
R and MATLAB a lot. I found that to be quite a natural way of programming.
Strawberry Plum. Okay.
Strawberry Pollock. I used some MATLAB. So let's say MATLAB was weird for me. It was a weird experience. I didn't enjoy it. R was much easier.
It is,
R
but
language.
those things are not really present in the modern web. So especially which is the dominating way of programming things.
I think mostly data engineering. They are present in like mainframe programming.
Maybe science. So having let's say heavy algorithmic things going on, but not in a typical application for doing a transition from domain to application. You have a total dominance of C languages.
Absolutely.
Languages. Let's go.
I guess
them.
that's why
good or bad.
I guess that's why R was interesting to me, because R had this sort of C-like, like there was a little bit of procedural syntax in there that allowed me to sort of wrap my C-like language brain around the functional concepts.
I'm so bad in math. I never used those actually.
I just use this for visualizations and like matrix, like machine learning and regression problems. Statistics primarily.
So let's go ahead then. I have moved set up the pace a little higher.
Yeah, that's okay. I hope our viewers won't be too upset.
It's a double-edged sword. Although I err on the semantic side, I like the expressivity. If you've ever done any Forth,
I've not done
Forth
Forth.
is another one of these languages that has almost no syntax. Smalltalk, another language that has almost no syntax. There are a few languages like that. And they become very expressive because you're not constrained by this big syntax iron curtain that drags around you all the time.
Yeah.
Mm-hmm.
But
Nope,
you
I
have
get
freedom to kill yourself.
So that does that mean? Because I've heard this stated before, and I don't quite understand it because I don't have the experience with Lisp to actually like really concretely understand this. Besides for a square on a blackboard, that every kind of Lisp program is almost its own unique language onto itself. Does that kind of follow up with, because you can kind of define everything yourself because there is no real syntax, as you say, and so people kind of really create their own structures in every kind of unique way.
Sounds like JavaScript vanilla.
It is.
And so when you go from one to another, you have this like you kind of have to adopt the person's mentality who wrote it.
This is generally true of every language, right? When you're a programmer, what you're really doing is you're inventing another language to express your problem in.
Mm-hmm.
In Lisp, the syntax is so sparse that all you're doing is inventing another language to express your problem in without the constraint of the language syntax. The language also has a number of features that make it very easy. Features is not the right word. Affordances is a better word, that make it very easy to add facilities to what appears to be the language. I'm being obtuse on purpose, but there's no other way to say that.
I see a lot of that happening in TypeScript.
I think I understand what you're.
I say.
I see a lot of that happening in TypeScript, right? So we create like meta types and parameters. Like I want this type to be a discriminated union with that other thing, or hey, I want the type from the React framework prop thing, but I want to add something of mine that I want to be controlled and dynamic, or I want, there is something for me that is domain specific and coupled to the framework, and I would like the type to denote that and separate it out, right? So I think TypeScript is sort of opening up the gates to allowing that sort of meta expressiveness in the language itself, where we're creating tools to express, is this expected? Is this an autocomplete helper? Is this used as a
This typical
validator?
three-state Boolean like true, false, null, where you have this typical union type in TypeScript, where you say if you haven't said it, it's null, but if you know the result, it's true or false, and then you basically have two states and then another two states.
Yeah, you're basically creating monads on top of
exactly.
System
So this is,
TypeScript.
but it is systematically. It is not loosely done like in JavaScript, where it can be everything. So you define it up front that it only can have those three states. And if you still have a fourth state, you have done something wrong, right?
Yeah, and you also can't in JavaScript because we don't have enough flexible operators. So one of the things that functional programming is very well known for is pull operators on lists. Right, so you can define link queue, if you know it from C#. That is a declarative style of writing queries or traversing a cursor after a query or statement was prepared. So you can basically tell it what it should do and add things on top of it, reactive programming, similar to RX. And then once you execute it, it will follow it backwards, doing it live for you the first time it's iterating through the array. It's not the same thing in JavaScript. In JavaScript, you say map, 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 filter, 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 filter. It will create a new array for each procedure. You actually have to go out of your way to use generators for that purpose. But we don't have reduction. We don't have the folding functions for the generator style, for the poll
Is
style.
there a definition for functional programming? Because people in React, for example, they refer that they do functional programming there.
Yeah, because that's a hallmark of immutable data structures, right? If the data structure is immutable, I need to be able to pull transform it, not copy transform it, right? Like you would in JavaScript. You go through an array, iterate through an array, create a new array, but I can modify the array, and then I sort of need to keep track of which one is this? Is this the old one? Is this the new one? With immutable data structures, you can reference the old data structure because it couldn't possibly change, which is quite specific for functional programming languages. It's also why languages like Elixir or Erlang might be difficult to grasp for a more C-like procedural mind. But let's continue.
If I were to re-say that, it sounds like you're trying to say that the language allows you to make things that look like it's a part of the language and not something you've created. Thus, this whole idea of you kind of invent your own, every Lisp program is its own language unto itself is partially in some sense true.
Yes, that's certainly true. Again, I'll say also that every programming language does that, but it's most pronounced in a language like Lisp.
Okay, so how do you reconcile, because you may have heard of Clean Code, how do you reconcile some of the approaches that are suggested in there with a language like Clojure? Because it sounds like Clojure is much more Wild West and has very few constraints.
So you have to be more disciplined in Clojure. Because you can go off the deep end really fast. But the Clean Code book is all about discipline. So the ideas in the Clean Code book move very well over into Clojure. There's no real friction there.
Okay.
I like to keep my functions nice and small. I like to keep my names expressive. I like to keep my modules relatively small. All of that is very easy to do in Clojure.
Does it have a concept of interfaces?
Yes, it does. You can have polymorphic interfaces. There's like 3 different ways to do that. Since Clojure rides on top of the Java stack, you can actually create Java interfaces that a Java program can call, although you're doing it all in Clojure. And you can also call Java interfaces from Clojure. So the interoperability between the Clojure language and the Java stack is almost perfect. Not quite, almost.
Yeah, okay, that makes sense. I mean, a lot of the JVM languages you can kind of call between. We did a lot of Groovy. You may be familiar with that.
Yep.
That idea. We'll call it an idea. I did a lot of Groovy at one point, and it's I mean, you can call Java functions really easy. A lot of concurrent hash maps and all that, but it was an experience nonetheless. Kind of working between JVM languages can sometimes be fantastic and sometimes be a huge pain. So, all right. So you've been off in the Clojure land and all that, and there's a lot of newerish languages. Go and Rust, I think, are probably the 2 most big kind of splashy new languages, if you will, call it new and splashy. That a lot of people have been kind of very excited about. How does Clean Code intersect those 2 languages?
I don't know a lot about Rust. I've only kind of looked at it cursorily. Go, I'm a little more familiar with it.
I think we are now getting to the first topic, which is Clean Code. So maybe for everyone who's not aware of that, Uncle Bob was, so the guy with the white hair here, was the author of the very, very known book Clean Code, Clean Coder, right? And others. So it was a series of typical. Wait, I have it here, right? No, Code Complete. I think it was Clean Coder. No, it wasn't.
I have Code Complete as well. He did definitely not write Code Complete, although Code Complete
no, Code Complete was just
right.
I thought it was the same blue book, but it was another. I think it was Clean Coder or something like that. But I have it at home, not here.
It is the Clean Coder, yes. Clean Code, Clean Architecture, Clean Coder,
clean
and then a lot of different, like, if you have a book with like a galaxy on its cover or like a star or universe, it's probably one of Uncle Bob Martin's books, because he always has like stellar objects on his book covers.
Interesting. I don't have it here, right? But it's actually a quite interesting one. I've listened to them. This is the problem. I'm listening to so many books actually, because I'm having a lot of time riding bikes, something like that. And I have listened to them. So I was just thinking why this blue covers were always, but it wasn't. Never mind. So this was the guy, and now we're going into the topic, and I think this is a topic, a good topic for Dennis to give a wrap up after that one. What you think about after the next section? I hope.
Done a little bit of work in Go. Go is essentially C with a couple of widgets attached onto it, and very easy to do clean code-ish like things in any language that's derived from C. And any of the C style languages, clean code is real easy to work with. In fact, I'm not sure there's any language that you could not apply clean code to, except maybe COBOL.
Well, COBOL is very, very unique unto itself. I've only done probably like 10 hours of COBOL. It's very, very tricky. People are also saying, and Perl. Is this true?
Trick.
Is Perl also clean codable? Probably not. That's okay.
That's debatable.
I have a friend that may or may not be in this chat whose mother programs Perl full time.
Wow.
I know. I didn't even know that was a position. I didn't even know that was possible.
Permanent Perl programmer.
Permanent Perl programmer, the triple P. All right, so let's get kind of into some more of the fun stuff. So the general goal here today is that I'm not trying to make this into some sort of debate. I think debates largely the purpose of a debate in my head is that you try to make the crowd think like you and not necessarily come to any sort of agreement or understanding of one another's argument as much as it is to try to defeat the other person, if that makes sense. And so I want this to kind of be more of like, how do you think about things? And then I'm going to try to represent as best I can, maybe Twitter's general thought process / Twitch's general thought process, which by the way could be very room temperature IQ, for you to kind of talk back and forth with. Does that sound good?
Sure, that sounds fine.
All right, so I
format.
For me, the most important question to ask is that in the last I'd say about 15-ish years, because when I went to college and when I started going to college, it was Clean Code, the Gang of Four, this kind of we also had Java as a primary language of learning programming with.
We're the same
was a very
age.
like important part. When I would go into interviews, it was always like, all right, tell me the design patterns that you know. Can you explain this in these terms, right? Solid was brought up a lot, all that kind of stuff. But then as time has gone on, it feels like that's no longer talked about. I really don't ever hear the term design pattern ever discussed among anybody. What kind of has caused this shift? And do you think it's a direct shifting away from something like Clean Code, or is it just a nomenclature change among people?
What has caused the shift is what has caused that shift in the last 50 years. It's the same effect. And the effect is that the demand for programmers is so large that the number of programmers in the world doubles every 5 years or so. And there's no way to keep up with a way of thought when you've got a doubling of the number of people.
I think this is an interesting point now. So I think this is roughly true with the amount of programmers doubled, because when I was younger, there were basically I don't know, not many programmers out there, mostly nerds, and some student guys. And these days, let's say, sorry to say that, but very normal people do software development right now, and a lot of them. And we see so many boot camps. We see so many more graduates out there. So many fresh blood in the ranks of software developers. And I think the entire discussion about clean code and how to do things, how to use principles, how to use React properly, because this is the most used by those younger generation developers. Those topics are so hot right now because there is a big, let's say, the gap, the skill and the knowledge gap between developers went up as well. It's wider as well now. So the young developer today is 3 to 6 months into the job, never done anything before that, and suddenly is a developer. And back then, so when I started, you needed to do at least 3 years of studying or 3 years of making an apprenticeship you can do both,
or
actually.
3 years just trying to build a non-trivial website or providing a service for somebody.
Everyone who's done that had already experience in the amateur area before that. So no one just started and said, "Oh, I need a job. What good. Well, I can do programmer, right?"
Yeah.
It was like, hey, I was doing that already when I was young, when I was a kid, on my C64, blah blah blah.
I was coding since I was 6, so
right. So
it was a very natural career path for me.
Exactly. So it was clear for everyone who's joined that ranks, and you were listening to those people who were then called nerds, geeks. We were calling them or ourselves back then like that because it was normal for us to be like that. It was programmer guys, right? And I think this is one of the big things why we even talk about those books again, because they were pretty unknown to me and my colleagues let's say 10 years ago, because I don't know, we've just done those things and they were common sense. But these days you need to promote them more again, because the knowledge gap is that high that you have this demand on the market for developers, but the developers don't fit those demands anymore like they did in the past, which is a huge problem. Especially when you run your CTO groups, you hear that very, very often, that it's extremely hard to find decent new people for a specific
Well, it's
role,
also difficult to define what decent means, right? So what Uncle Bob mentions is that because the pool of software developers grows, it heavily dilutes towards inexperience. So every few years, the term 3 years of experience means something else, right? So if you heavily dilute towards one end of the spectrum, then the people 3 years from now, the people with 3 years of experience have a much lesser quality of 3 years of experience than somebody with 20 years of experience, right? Because the person with 20 years of experience, their first 3 years were monumental. It was career shaping. For somebody who just came in from a boot camp and basically learned how to build arrays and iterate over some basic control structures, it might not be career shaping or just personality defining as a engineer or as a coder, as a programmer. However, in the same way, there are a lot of people who come from university, from boot camp, and they are super lead coded up with a lot of academic CS background, and they have zero experience in the industry, right? So you have people who work for Netflix or FAANG companies for 2-3 years, and they have very little engineering experience, but they have 10 years of academic CS experience.
Yeah, the point is, after, let's say, 3 to 5 years of or let's say school experience in any form, right?
Yeah.
You just then start as a junior, right? As a boot camp, you start after the boot camp as a junior, which is, in my opinion, a pre-junior level. So this is how I call it myself. It is like you are not so you cannot work on your own right now when you just leave boot camp. It is not possible. Sorry to say that. It is
too many
totally
technologies. You don't know how to put them together.
It's totally fine, but we need to accept that you can't just do a boot camp and then expect to have learned what other people have learned in 3 years at least.
Yeah, boot camps give you a high degree of confidence because it shows you, it holds your hand, putting a lot of technologies together for like one project. But then whatever you end up working for, whatever company you end up working for, will not use that exact same company of same combination of tools. So your bootcamp experience will quickly diminish and put you back into like a low confidence area.
So you need somebody there unforeseen circumstances. That's the biggest problem. Yeah. So when something went wrong and it's not the language, it's something on a lower level, something. For example, you are in a React world, so most bootcamp people do React in some way or another.
Fair.
And then you have a problem with NPM, for example. You have a problem with the packages. There is something wrong on this side, right?
And you lean towards underestimating how long things will take to figure out. That's why business owners don't want anybody. They want their juniors to have 3 years of experience. Because they want some level
this is what decency is. So decency doesn't mean very good or very bad. It does mean you can fulfill the role. So if you specify a junior role, you expect a person to be able to do it, right? Yeah. And not to learn to do it. It is not a, let's say, extended boot camp. And this is what we need to learn and accept in that moment. Okay, let's go ahead.
Let's go.
Pouring in. Right? So you might have some thought leaders from 30 years ago who had some really good ideas. Those ideas have been swept aside by the wave of people just pouring in. And it's very, very difficult to maintain any kind of consistent mode of thought when you're in that kind of demographic deluge.
Yeah, no, that makes perfect sense.
One of the things I try to do is yell out enough so that people remember some of these things and bring them back into the present so that they can look at them and go, oh, there are these things called design patterns. Gee, I didn't know anything about that. Well, maybe you'll know how to read something about
this. This is how to raise
kids.
By the way, you need to yell
the design patterns book is probably the most important book written in the last 30 years.
Or
and it's been swept away by this
ThePrimeagen has 4 kids. Did you know that?
Do you think that a lot of modern software can have the same benefit with these design patterns? Because I'll tell you, like personally, I pretty much am a strategy pattern guy. right? I think the strategy pattern really is the basis of all patterns, right? I mean, it's pretty much life is strategy. That's pretty much just use an interface. Do you think that much beyond that knowledge and the builder pattern that there is a lot of usefulness still to continue to like dive into these patterns?
Well, there's a ton of usefulness to it because the purpose of a design pattern is to have a name on a structure. So I can say to you, well, I think we ought to use the visitor pattern here. And if you know what that pattern is, which you're right, it's just a bunch of strategies. But if you know what that pattern is, then that structure snaps into your mind, and you and I can have an intelligent discussion about it, and we can have a discussion of the pros and cons. Or if you're sitting there reading code and you see, oh, this is the XYZ decorator, and you happen to know the decorator pattern, then the structure snaps into your brain, and you don't have to work it out by reading the code perfectly. Right? That's the whole point of design patterns. It's a way to take one notch up on the level of abstraction so that you can look at things in the code and identify them without having to go line by line by line by line.
Yes. Okay. No, I mean, that's a very good answer.
You know,
because, you know, we often have a lot of data structures or algorithms.
Quickly, because we have talked so much about JavaScript, for example. JavaScript is an extremely interesting example for that. I just read right now a post on LinkedIn. It's just another tab open, where it's about actually when do we have some long-lasting structure again, and the question is, especially in regards of modern languages like or let's say React, for example, in the front-end area. So always coming back to React because this is one of those themes of this show. React is just a pattern. It does do some things magically in the background, but
controversial. Like
but if you work long enough with React or similar language, similar libs in this case, you get to the point where you understand how every page is working. Reverse engineering is just a matter of seconds if you have done
sort
it right.
of.
It is.
I would disagree with that because that's exactly how we thought about model view controller in the early 2000s, and Zend framework did not work the same way as Ruby on Rails, even though both of them were the same pattern.
But those are patterns. I'm speaking of a React environment and another React environment. So if you switch between, I never had a problem taking a look into another code base of another company and basically have problems to understand what's going on. Sometimes, especially when you have those big ball of mud components, then yes, but this is a clear mistake, and we're coming to that because of clean code and stuff like that. Yeah. But as long as you follow the best practice patterns, the React manual, for example, then you have a very standardized way of working since years now. And I think this is something people still don't understand and don't value enough, because if you do that just in the vanilla way or with any other language, just, you have a plain language to just start with, every project will look like the very first weeks of development will shape the project to its uniqueness. And that might be interesting for the project. So you have more, but it first of all, it raises the upper ceiling of complexity a lot, because it is probably done by senior developers and they shape something they understand, but probably doing it not in a simple way that everyone can work with them on the same level to understand what they actually see there.
But it's also not self-documenting. Like you can't just open up React and write React without knowing the patterns. It's very difficult to write React, to create to do engineering inside a React application without knowing the higher order constructs of the patterns.
Exactly.
I'm not talking about the library. I'm talking about understanding how the data flows. Nowadays, what are hooks? What are signals? What I see in all companies,
including mine, is that every time a company starts with React, it's like baking pancakes. The first one is always shit. The second one then is better, because in the first iteration, you actually learned how React is actually supposed to work. And then you understood, I actually moved patterns from my old world into React and tried to put it onto React, but it doesn't work like that. And this is the reason why so many startup companies who just start with React because they took a look at state of the JS end up with an early legacy system, which is actually not really working, right? They have rendering problems like hell. They have no linter in place.
But it's also declarative. There is a declarative nature to how the components are structured, which is a very different programming paradigm. If you're coming from a imperative jQuery style of writing JavaScript in order to make HTML interactive, that's like apples and oranges. That's very difficult to wrap your head around.
And it will destroy the app on some point if you overextend that. Just as I mentioned, I think let's get back into the thing. But I think this is one of the reasons why why we should try to implement standards, clean code, or try to even if the clean code in the book is not so. The idea, the practices behind that is not good for you.
He'll explain it. It's
okay, that's good.
Yeah.
I don't know the video.
And if I say, hey, this is a general tree, you already know what a general tree is, right? I don't have to explain to it that you have 0 or more children, right? Like that's just not a thought process we have to have. So therefore, you can make the argument that if we know what a builder pattern is, and I say, hey, let's use the builder pattern, you and I are both probably thinking something that's very, very close to the same thing. It may be slightly different, but for the most part, at least close to the same thing. Okay, so I think that's actually a pretty reasonable argument for design patterns. But one thing, can I say it this way, that a lot of times what I see is that when people kind of are really into this, because remember, Netflix was a large Java shop, was there for a long time, and so there's a lot of patterns. I often find people reaching first for a pattern and an abstraction before the problem is ever solved. What do you think about that? Because I know you're very into the design first and then program kind of approach. You said that in Casey's, you said that in Casey's here. Let me bring up your exact quote. Sorry, I did do like a little, I did try to at least read one thing, right? You said, it was the latter zealots who thought it was better to leap into code without any forethought. And that was kind of like, there was some context to that, of course. But the general idea is that some people, or your suggested ways to like kind of design all things, and you kind of create the abstractions and think about the structure of your code before you start coding. Is that correct?
Yes.
Am I correct on that one?
Yes, with caveats, but yes.
Okay. A lot of like modern, or at least what I would call modern thinking, at least like the Go way of thinking, is that you kind of almost do somewhat of the opposite. That you don't reach for abstraction first. You actually try to get the thing itself first out, and you allow the abstractions to more naturally percolate or manifest themselves. How can you kind of resolve those two school of thoughts?
So I don't think there's a resolution there. So the way I work is that I will do the most concrete thing first. I will think about the problem, and the amount of thinking I do is an hour, maybe. Okay. And maybe I'll scratch a little design on a whiteboard or something, or a piece of paper, and I'll think about it, and then I will enter it if the problem is large enough. Then I will do that, and then I go right for the most concrete thing I can, and then I have the problem force me to become abstract. As I'm adding more and more code, it starts to get harder and harder to add that code without adding an abstraction of some kind, and so I let the code force that abstraction upon me, and I continue that process. And typically, you wind up with an awful lot of abstractions once you follow that process.
Do you ever, knowing, like, so let's say that you have, like, it's hard always to come up with these examples kind of off the top of your head, but you have something that you could easily see into a series of if statements or switch statements. Like, right, you have a message type that you're going to be handed. It's a string. And the first one is just message. And then the next one, there will be more, but there might not be many. How do you determine when to abstract versus when to go, you know what? If there's 3 hard-coded strings, I'm fine with that. Like, when do you make this decision?
For me, it's a kind of feel thing. As I'm working in the code, I look at it and I get this itchy feeling in some part of my face or gut, and I think, oh man, that's going to kill me later on. And at some point, that
quick interruption, because I like to interrupt. There is this point why we on LinkedIn and on the streams and when we're doing live coding, we're always like arguing very quickly and very early on was that actually most of the people are acting like this. It's about the gut feeling. So there is not a specific thing where you can say, hey, I could measure the moment when it happens that I need to abstract something, especially not in early development. If you don't have patterns, if you are very early on in the process. And I just wanted to point out that this is one of the reasons why we have so many arguments on LinkedIn, on other platforms about how to actually doing those things. But I think this is a good explanation that it should be some natural progression. And as more you work this plays together with why I'm loving the synchronized code review pattern instead of the asynchronous one, because you talk more about those things and you can connect and average out that a little bit more over time than just doing that by a, let's say, anonymous review version.
But there was a little bit of abstraction. There was a little bit of resistance there. So I noticed the way ThePrimeagen, so his name is Michael, the way Michael asked the question, it was implying that the modern day, Kent Beck says, make it work, make it fast, make it right, or something like that. I think is that sort of proverb.
Something like
and it's this idea that, don't abstract until you know how to express the problem. But Uncle Bob is talking about something different, right? So he's saying he first needs to understand what he's building in order to then create something concrete. Right? So my main critique when I see people create abstractions too early is that they abstract things that are not concrete. Oh, I will start with a singleton here and I will create a builder pattern around this factory. And when they're done, there is nothing concrete to show. What do I mean by that? Concrete means that there is nothing of value that I can test. And he will get to this point when it comes to TDD. Right? So if I'm designing something, no problem. As long as it is concrete, as long as I can say it fulfills this behavior, it has value in this kind of problem area. Right? So for example, if you've ever done a pathfinding algorithm, one of the first things you should do is traverse a cheat and just traverse a random path, or you predefine a path. I know this one solves the problem. And a lot of people don't take that choice. A lot of people think, oh, no, that's fake, that's cheating. I need to abstract away first traversing the graph. I need to abstract making the graph memory efficient. I need to make the algorithm of how I choose left or right efficient. And I need an algorithm for the heuristic if I'm doing A star versus Dijkstra, right? So, and they create all of these abstractions up front, designing the system, but they are never concrete, which means it is also never testable. That would be my main criticism. Like that, I wouldn't recommend, right? So that when he said, I think about something, how to design it so I can make it concrete, that concreteness is a very, very important condition, because that is the way that we do TDD. I have to think about the problem to know how to describe the test. If I can't describe the test, I can't make it concrete. I can write code and run around in circles, but I can't deploy it. I can't integrate it. I can't make it provide valuable information.
Yeah. Yeah, that's actually a good point. You need to get, you need to get, so.
You need to ground the code in reality.
I think this is the reason why refactoring is such an important part of TDD and other practices.
It maintains concreteness.
Is that you're actually going forward first, and then you have created the value, that then you don't change the value, but you refactor in order to get back to the qualities and meet quality like maintainability and stuff like that.
Mm-hmm.
But you can't, as you said, you can't abstract something which you don't know yet. And if you try to, you create a lot of overhead, and you basically make it impossible to reach the actual point where the concrete point is. So you make it harder to get and understand what it's really about. Oftentimes, because we are humans, so we need to have it in some form of exploration mode, let's say, to get from A to B, understand B, which is then the end, right? So the end result. And then we're going back to A and refactor that. So it is basically doable for others or for yourself in some days again. And you can reuse those things maybe somewhere else. And this is actually real application of design principles like Yagni, for example. Abstractions, Yagni, maybe later, right?
Maybe
so
later, yeah.
And this is about it. But take a look if you really need it. And I think this is one of the most controversial things about TDD, because people think that you need to do all the abstractions, test them, and then you can't move again. And this is what people don't like, because most developers I personally know don't test at all, especially in the front-end area. And this will be a topic, by the way, next week, Wednesday. And this is, so they really like to have this extreme being concrete something. But they never go back to refactor.
True.
Actually.
Concreteness is very real in the front end, because you need to see it, and there is too little logical decomposition. But more on that on Wednesday. Right? More on that on Wednesday, because we did 20 minutes of the video in an hour, and the math doesn't check out for me.
Statement with two cases.
I can change the speed again.
No. It's going to be too fast.
Do you have a number that you put on it, or is it really just only feel? Like, can 5 be too many? Like, is there ever too many?
Well, I think, yes, you can say 1,000 is too many, but
agreed, yeah.
There's no hard number, because it all depends on the context, right? If I'm putting together a program for a demonstration that I'm doing and I'm going to throw it away, I'm just not going to worry about it very much. On the other hand, if it's for a client and the client has a long lifetime and they're expecting to make a lot of changes to it, then I'm going to be a lot more careful.
Okay. Have you ever had a situation? Let's kind of keep on going with this whole message thing, right? You're coming up with some sort of custom protocol that's going to have a various set of commands. Have you ever reached for abstraction first and then regretted it?
In my younger days. It's a hard lesson to learn, right? Because abstractions are beautiful and they're enticing and you want to do them and it looks so grand. And after a while you learn, well, abstractions come at a cost and you will pay that cost as soon as you use the abstraction. And it will not pay you back unless there is some reason to have that abstraction there. So in my younger days, I did a lot of that, but having become old and jaded, I try to stay as concrete as I can until I'm forced out of the concrete world.
Yeah.
It's funny. It's funny you should say that because I often, we have enough people hanging around here. I don't know what we're at right now. Let's just grab it a quick number. 3,400 people currently watching, and I often see kind of. It's very hard to tell somebody a lot of these rules that I've kind of come up with. Like, why do I approach software in this kind of specific method? And a lot of it just comes from the fact that exactly what you said, which is, well, one time I tried to make a game and I had 7 layers of inheritance. You want to guess how much I hated that experience? Yeah, I really did hate that experience because not all burgers are cheeseburgers. And eventually you're just like, I just need a whole new burger archetype. You just lose it. And you kind of have to go through this experience a bunch of times before you kind of have like a general feel of software. And based on the things you're saying, you're actually not really far either from the Go philosophy. Like, it is good to sit down and kind of think about what, kind of what you want to build here. I generally don't feel like I have to think hard in the sense that whenever I give a problem, I just know the structure I want it to be, and that is usually good for what I know what the inputs should be. Which obviously all good plans die at first contact, right? Like they never go past that. So it's like, oh, I was totally wrong about like 8 of my assumptions. I guess I have to redo all these things. Have you ever been into the UML days? Like, was there a point in your career where you were like big in the UML? And
oh yeah, absolutely.
I was changed your mind on it.
Grady Booch.
Okay, because I'm curious about this because I was so heavy into it. That's where like all my 7 layers and all these things came from. Was that I was UMLing and dotting and composite. I was really into it.
Oh yeah, yeah. No, me too. And I still use UML from time to time. I'll draw some diagrams on a board. I know how to do it. But that was a time when we thought that we could capture software in a very abstract way, and the goal was for high-level analysts to draw these diagrams, and we wouldn't even need programmers. We could generate the code from those diagrams. That was completely ridiculous failure.
I may or may not have generated some code from UML at one point in my lifetime.
There were many tools. that could do it. And there's still, you can do it in IntelliJ today. You can draw a UML diagram and it'll generate code for it. But who cares? You don't want to generate code from a diagram. That has been tried so many times. And it has failed every time. It's like it's always the wrong solution unless you have an extremely constrained environment.
Yeah. That actually makes a lot of sense. I feel like if you are purely working in a black box, you effectively can engineer that solution out because like everything is known. There is no questions, right? Like I had something I had to build a long time ago for a little bit of a satellite that had 256 bits. It's like, you know what? I could test every possible pattern, or there's 256 possibilities. It was 8 bits. It's like I could test every single possibility, and we can actually design this to the 100%. There is no, there is no possibilities that we won't be prepared for. But that's kind of where I lost my UML mojo is after that, because I realized that as I kept going, I kept designing these things, and then again, first contact with the enemy, and my diagram was completely wrong. And I spent so much time on the diagram.
Oh yeah. That's always a problem. And back in those days, we used to think that this is before Agile, before the Agile movement. We used to think that you should spend weeks and weeks on those diagrams. Get the diagrams right first, and then the code will just pour out. Well, that never worked.
Yeah, I spent 6 months on one, and it made it 3 hours into programming before I realized that I made a program so slow for a supercomputer it couldn't run on a supercomputer. And I was just like, oh gosh.
We smoking, man.
It was bad. 6 months to be destroyed in 3 days or 3 hours. Okay. Well, speaking of Agile, that's pretty kind of a hot topic here. How do you feel? Because you obviously signed the original. You're one of the signatories or whatever they call it, whatever word they use there, of the original Agile manifesto.
Yes.
How do you feel like the last 23 years have gone since the Agile manifesto has come out?
I wrote an entire book describing my feelings about that. It's called Clean Agile. I'm the old fuddy-duddy who's yelling at the young kids to get off his lawn, right? The Agile message has gotten so badly twisted and torqued and perverted that I wrote that book to try and reboot the whole thing. Say, well, no, that's not what we were saying. What we were saying is something else. Agile was a small idea for helping small teams do small things. It was not the overarching pattern of software development that was to dominate the world. It was just a way to get 6 or 7 guys to be able to work well together.
Okay. So what made it fall apart then?
I can tell you that exactly. How long do you have?
I have to help my wife move in 26 minutes.
Okay, well, this won't take that long. One of us decided that we wanted, a Scrum advocate, Ken Schwaber, decided that he wanted to teach a course called the Certified Scrum Master course. And he came to me and he said, hey, Bob, can I borrow one of your offices or one of your classrooms so that I can teach this? And I said, yeah, go ahead, Ken, that's fine. And he taught the very first Certified Scrum Master course. And the idea just took off. Everybody wanted to be a certified Scrum Master. Not one programmer wanted to be a certified Scrum Master. All the project managers wanted. They wanted that little checkbox on their resume. And the project managers flooded into the field. They flooded into Agile. They took over the message. They took over the conferences. They took over everything. And they literally pushed the programmers out. And agile became a project management idea. And the programmers looked around like, they were left on the desert island and looked around like, well, how the hell did we wind up on this island? And why are they sailing away in our ship? That's what happened to agile.
I am going through this exact conversation with every single one of my clients during coaching, right? Because they ask me, how should I manage a team? And I always tell them, you shouldn't.
The team is managing itself.
The team should be managing itself. Like it's about engineers making engineering decisions. If you as a non-engineer are trying to manage a team of engineers, you will never be able to do so because you don't understand engineering.
Yeah.
Go sit with them and learn how to code, and then empower everybody in the team to replace you. And there are a lot of CTOs hire me mostly. CTOs, like CTO equivalents. And we always have this conversation because they know how to code. They know how to think like an engineer. They know everything that can go wrong. But they got accustomed to the Scrum-like way of thinking about project management that they think it's normal that a team is externally managed through something like Jira or a Trello board or some kind of Kanban board. That no, the Kanban board is for the team to communicate with itself and the stakeholders, right? The boards are there for everybody on the team to show to each other what the output of a 10-minute conversation was 2 hours ago. Right? Like that's the point. The point isn't to then use these boards to like use them as like long drawn out roadmaps and Gantt charts and how to translate between a Kanban board to a Jira board to a backlog to a Gantt chart to a roadmap.
Was actually there to close the gap between the engineers, that they are on the same page, doing the same things and working towards the same goal. And yes, you always have some form of stakeholders like project managers or product owners somewhere. But in the idea of agile, they are not above the team and connecting with tickets over a Kanban board. They are actually within the team, within the iterations, and they are actually software developers while not being programmers, right? So they don't really program, but they are sitting in between. They understand the problems and they understand the decisions which bring them towards the goal or bring them further away from them. Because oftentimes, and this is actually what I have every time, is the idea, so how do we get that this gap between business and development is actually closed? And people don't understand that if you just do your stuff with engineers only for 3 weeks and you get out of your hole as an engineer to the product manager after that, and then you synchronize with those people again, then you realize how much of a delta you have actually produced. And this is one of the biggest issues, because this is the very same as we discussed with languages in the beginning of this show. It is the very same. You don't know exactly what your iteration is. So this is the problem I have with Scrum. Scrum says in 3 weeks we want to have this. No, you don't know if you want to have this.
Well, I mean, the video will get there. The point isn't to say in 3 weeks we'll have this. The point is to say we made very small steps, and we can verify that if we make 5 steps in a row, each step is this size. So now we're trying to play a game where we can say, I think this project will take 2 teams making 10 steps each. So if everything goes right, it should be done in 3 months, based on our measurements. Right? So it's trying to ground estimates in reality by looking at past evidence of flow. But the problem is that if the team is too flow optimized and the team is constrained, right? So it is externally managed. It is the external management that disrupts flow, because the velocity counter from Scrum is only relevant if there are no external influences on the team. If there are stakeholders and project managers and POs influencing the team and they are not part of the team, that can never work, right? Because the team has to be autonomous for the data to make sense. Because look at it this way. You're measuring how fast I'm running, and you're ignoring the fact that I have to dodge traffic. So we're having an Olympics course, and there are random people on the stadium, right? Like people are, I have to dodge. I'm not in my lane. I'm not in an isolated environment. That's what Scrum is if the stakeholders are not part of the team. You can measure all you want, but I don't know who was in the way. I don't know when they got interrupted. I don't know when there's a third stakeholder having another pre-project intro meeting about that next project that's coming down.
Which is
after
the
this
reason
one's
why
finished.
we actually don't need Scrum. Just the original idea of agile is already enough, because we as human people already can communicate. We learned that as children, so we can pass the ball to someone else. The ball's coming back to us in the same room, in the same team, on the same day. We don't need to span that over boards, over days, over departments. And this is one of those points. Let's go ahead then.
Robert says, we have a comment in chat. I literally told my boss the only way to manage that is you go learn how to code. I would go a step further. It's not enough to learn how to code, to have the knowledge. It's important to be coding with them all the time, right? So the point about agile is that everybody who is involved with the product needs to be on the team, right? So
I wouldn't say that a boss, let's say in quotes, so a supervising person needs to be able to code. I don't think so. You need to be able to understand what's going on.
They need to be in the ship. Like they need to be in the ship.
And doing decisions as a team together, because this is sometimes very important, because software developers often tend to have not the same domain knowledge as stakeholders have. But if you move to stakeholders within the team, then suddenly it will be basically the devs will be infused by the knowledge of others, and then you have the real potential, and you can make those very short-term decisions and make adjustments to the directions.
Yeah, the book Team of Teams talks about this. Team of Teams and by Jocko Willink, the other one, what's it called? Complete Ownership. They talk about this concept. If you just look at a soccer match, a football match is very much an agile team, but it's the team captain who's on the field who is the leader of that team, not the coach who's sitting on the bench. The coach is the stakeholder. The stakeholder is screaming influence at the team because that's part of his Bill of Rights. But it's the team itself with the captain on the field that's actually making all the small tactical decisions that you as an audience member have no idea are going on. Because the camera, from your perspective, you're so zoomed out that you have no idea that there's thousands of micro decisions going on the field. You think they just play automatically following some simple rules, that it is some kind of like easy game that is perfectly choreographed. But it's the captain's influence on the field that is crucial to how the team operates. We just don't see that. And the same thing with a software engineering team. It is the informal authority for the team to have product power, to make decisions, to say, I'm cutting this feature. I'm going to let my stakeholders know. I need to change this feature. We're going to ship with a much more basic version of this. We over-engineered it. We over-planned it. I'm going to go talk to my stakeholders, start building it. The increment we wanted to be done in 2 days, actually, we're not there yet after 3. So we're way off the mark here. Go deploy what's done, stop work, extract what's done, deliver continuously, integrate, and I need to have a very painful conversation with the stakeholder, right? So that's what Agile is about. But it doesn't get across. Like the whole project management sphere of Agile certifications really missed the mark on that one. And that's what people, engineers included, think Agile is. So definitely fully agree with Uncle Bob here. Like it definitely went the wrong
Agile's
way.
a lot like communism. People just keep not trying it correctly. What is the correct way to Agile?
Oh, gee. It's a real simple idea, right? Do things in really short sequences, measure how much you get done in every sequence, use that measurement to project an end date, and tell everybody. That's kind of it. We can go into lower level details if you want, but that's pretty much it. Do things in real short segments, like 1 week long. Right? Measure how much you get done, project that out with an end date, and then tell everybody, hey, that's the end date that we look like we're seeing. And generally, that date is so terrifying that people are like, oh shit, maybe we've got to do something about this early enough to actually get something done.
Okay.
That's it.
So proper agile has no dictates on how the team accomplishes, or even the timelines or the weeks, days that are used to measure these short cycles. Shall we call them sprints?
Yeah, in Scrum, they're called sprints. There are individual implementations of agile. So there's extreme programming, there's Scrum, there's FDD, there's DSDM. There's a whole bunch of these processes that are more
just sound like drugs more than anything else. Are we sure we're on the same topic? I'm pretty sure one of those is the dream drug. I've heard about it.
Yeah, well, I think a lot of them are dream drugs, but they are more defined. Agile is not. Agile is just this framework that says, hey, do it in short cycles for Christ's sake. And that's kind of it. Now, I happen to be an extreme programming aficionado. I like the disciplines of extreme programming. So you and I could have discussions on things like pair programming and test-driven development and refactoring and simple design and things like that, where we could get into a lot more detail. But that's just an extension on top of Agile.
Okay,
that's an important point.
I mean, I like this topic a lot. We don't have a ton of time, so I don't want to linger here too long. But I mean, to me, that this mostly makes sense in the sense that, as far as I can tell, I think Netflix is one of the best executors of Agile in the sense that no two teams operated the same. Every team was independent to choose their process, how much process they wanted, what is their cycles, how are they making promises, how are they interfacing with other teams. Like everyone was their own kind of tower onto themselves, and it largely worked for quite some time. Obviously, as things kept growing, there's always friction no matter which way you choose. We always said we choose people over process, which I think is the right kind of way to go about things. I think that is very agile in sense. But it's kind of good to understand kind of how the breakdown effectively happened, and it makes sense that if Agile is not applied on the individual basis, it becomes a series of meetings and all that. How do you convince like a company that are doing Agile wrong and that you should leave it up to individual teams and individual teams should make their choices? Because that inevitably suggests chaos, right? Like there is a level of chaos to that you cannot control if two teams decide two different release cadences.
Yep. Yeah. Where Agile breaks down is when people try to put an overarching envelope around the outside and then demand certain behaviors across the board. Yeah. It just was never designed for that.
So how do you convince someone that they shouldn't do that, right? Because that's largely how Agile is kind of practiced today. Is that it's like everybody, it's stand-ups 5 days a week for everybody. We do this. Like how do you say no? Let those 3 people make their own determination. Let those 5 over there make their own determination, and then they will figure out how to talk to each other. Like how do you convince management of that? Because that sounds like the Wild West. Sounds like chaos.
So I do that by writing books and yelling at people and things like that. But how would someone do that if they were trying to introduce Agile into an organization?
And let's introduce Agile into an organization with Scrum, shall we say?
Oh, okay. Yeah. How do you bring Scrum into an organization? So,
no, the
that
inverse.
has always been. Sorry, say it again.
The inverse, that it already has Scrum. The kind of the ridiculous. You're like, now let's introduce Agile. How do we introduce the actual concept into this place?
How do we undo the Scrum poison?
Yeah.
I don't know how you do that. I don't know how you convince people to behave in a different way. My whole career for the last 30 years has been in trying to convince people to behave in a different way, and I've had some moderate amount of success just by yelling loud and publishing a lot. But when I get into an individual company, it's very, very difficult. What will happen to me is that I will wind up leaving that company with 1 or 2 people who kind of got the light bulb on their head, and then they leave. They leave the company and they go somewhere else.
That might not be the best selling for your contracting at all. Be like, by the way,
happens
you bring me
all the
and you lose some employees.
Well, I don't do that anymore. I don't do any of that stuff anymore. So
Got that one off. Yeah. All right. I want to get to the things that I think are more probably exciting for me. So I have a really dumb rule of thumb when it comes to programming. And it's a personal rule, right? Which is that whenever I see columns exceed 80, I generally think, what am I doing here? Now, I don't have a problem with columns exceeding 80. It's just kind of like a general heart mentality that when I've done that, I kind of look back and go, man, I probably have a bunch of maybe I have a nested function in here. Maybe I have 2 for loops that are nested. I've done something here that's probably slightly unusual to get out this far, unless I'm, of course, programming Java or C++. Then it's, then you have to extend that line to a new position. You have one, which is you don't like functions beyond 4 to 6 lines. That's your kind of smell. How did you arrive to that? Because I have a few questions on this. So how did you get there?
So first of all, on the line width side, I don't set that at 80. I set it at 120. I did a statistical analysis on that and found that if you go beyond 120, you're outside of the vast.
It's a great analysis, by the way. If you can find the right.
Mine is completely irrational. So I'm not saying that you have to have rationality described. This is just my feeling.
It's punch card width, so that's rational. 80 columns. We've been living with that for 50, 60, 70 years now.
Yeah.
Function width, function height, right? The number of lines in a function. I don't really have a limit there. I have said a number of times that I like 4 or 5 or 6. I think that's a good size for a function. If I ever get a function that's 10 lines long, it's not like I'm going to throw it out. It's like, it's 10 lines long. I wonder why. And then I continue on. I like them to be small. And the reason I like them to be small is that if a function does more than one thing and I can pull the 2 things apart and give them individual names, I find that to be more readable. That's the bottom line. That's the only reason.
With the inverse, could you say this kind of an inverse, which is the more functions you have to go through to understand what is happening, also the more contextual overhead you have to have? Because I can imagine if I had to have 20 lines on screen that kind of describes a few-step process, I can kind of keep that in my head because I don't even have to like use an LSP. I don't have to use anything to jump to these definitions. They're just like right there in my head. But if you're always splitting these functions up, it can also be
LSP.
difficult to be like, okay, what does this function do?
Such
Okay,
a
well, this
Vim
function's broken
user.
into 2 more functions. What do those 2 functions do? Okay, now understand those 2. Let's undo that one. Let's undo that one. Let's go to the next one. Okay, now we got to go. You kind of effectively build a tree in your head of what is happening. How do you prevent that type of explosion with that type of rule?
So I don't prevent that type of explosion. If that happens to me, there's a single keystroke which will just pop those functions back in, the inline refactoring. So in IntelliJ, I can just go, Control Alt N, Control Alt N, Control Alt N, and it puts that whole function back together, and I can read it. So if I find myself in that situation, then it's easy for me to undo it. I also then realize that I had partitioned it incorrectly. Because if I find myself in that situation, it's because I did not put those functions apart correctly. I did not give them the right names. So that's a test for me, right? I can undo it and then redo it in a different way that maybe flows a little better. The fear that you will drown underneath a sea of little tiny functions is not a very good fear. What you want to do is state what each function does, give it a nice name, so that when you see a function and you read it, you understand what it's doing without having to read the next function down. If you can get that goal, if you can get it so that you can read a function and not have to understand the next 3 functions down, you've gained a big leg up on the problem of understanding what a system does.
That's very...
Yeah, I feel like that's true if mutation is low. In the sense that if you have a...
I think I've done so much refactoring and repairing of code bases in the last 4 years. So much, really, so much. This was my main job. So I on some point I like to do something new, but instead I was just fixing things. And the point was exactly what was pointed out right now wasn't there. And this was the reason why we needed to do that. It was not like the code was not working. It was like we were not able to work in that code anymore. And the point is that if you if you have then those files where you have a very short file with a rough overview of what is going on as some form of index, right? Like a contents section. Then you see, okay, this is happening with very long function names where it says this is doing that and that, this is doing that and that. And sometimes even with the expectation behind that, especially in TypeScript, it's interesting to see the, let's say, the result of that as well. That helps so much in reverse engineering and helping to understand when you need to do something, fix something, change something, add something, you need to so you don't need to spend too much brain power into where and what happens as side effects, because with that you reduce the possible side effects to nearly 0 if you do it right. And this is something which I think for me, it always was the most fundamental point of clean code, to get it understandable for everyone in the same way. And this is the simplicity, the idea of engineering to reduce complexity.
It's also the point with functional programming and with newer styles of programming, like object-oriented programming that follows a tell, don't ask principle. By the way, we have an episode on tell, don't ask. If you YouTube our tech journey, tell, don't ask, we had an example of that. On the refactoring bit, I did a coding stream last week where I went through exactly the same thing. Of just extracting functions, naming them, getting it wrong, and then putting them back together in a different order that made it then easier to understand what's going on, and debug, and test. Because I was doing an example of test covering something that's difficult to test cover and requires mocks, but there's no abstractions, so I have nothing to mock over other than the whole end-to-end system. Yeah, I was about to say something, but I think we should just continue with the video.
Complex enough problem, right? Like if you write, let's just say any new modern UI framework, and you're in the driver's seat and you have to sit down there and you have to do the actual writing of the framework, right? That would be understanding what a function does simply by its name could become excessively difficult. If you've ever read through any of the source codes, anything like that, even though you can kind of understand it, you kind of have to read the code to first really understand what these names mean. And so that's always been kind of one of my problems, because what I personally find happen is that I have a lot of these smaller functions and you have a lot of this, and then you go to code review. And code review is really where I think a lot of these weaknesses kind of show up, because I can't look at the code without clicking around, hopping to different files, hopping to different locations, trying to gain it in my head, because it's like the code was written to be LSP navigatable, but not reviewable. If that makes sense.
That's a good point.
Yeah, I understand.
Can you pause here?
And I understand the experience. I've experienced that as well.
So
you get badly.
In context of what he just said, also in connecting it with Robert's comment that they had a linter check for this, I find that our experience was heavily diluted. So an LSP, so Primeagen is a Vim user. So you have to generally install your own LSP, which is a, if you're an IDE, an LSP is a protocol definition, is a language file that tells you how do I syntax, parse, and lex what's in the file so that I know what the main keywords are so I can jump to them semantically. If you ever written code in Notepad++, and it didn't have an LSP for the language you were using, you know how miserable of an experience that is, because you need to control F and then you look it up using the name, but sometimes the name is semantically not the same. It was just accidentally the same name was used, right? So you want the I variable inside this context, but you don't want all I variables inside this file or inside the project, right? So that's why this is important. However, I think we got into this sort of weird stage when the Borland tools and then later the Microsoft suite of tools came out. We saw this emergence of frameworks and languages, and especially application framework languages for the enterprise suite of software, where languages were shaped in such a way to be written or generated with an IDE. For example, I remember specifically when I started coding in Visual Studio.net for Visual Basic.net, there were, in order to get the Windows forms and to have animation in my Windows, I had to generate code that I could never possibly handwrite code like that. And the framework and the language and the IDE were set up in such a way that the code had to be generated. It would always be completely unnatural to write the code that way. And I see that a lot with modern frameworks, where if you're a Laravel developer and you're constantly using your code generators to bootstrap this and bootstrap that and give me, same thing with ORMs. I don't want to write the thing. Just I will create the type definition, or I will extract it from the SQL database, and then I want to generate my classes. Right? So it is very dangerous to say, I'm just going to optimize all of my auto-generated functions so that when I open it up in my IDE, the IDE can sort of point me in the right direction rather than it making organic sense. Right? So I think this over-reliance on the IDE will help me is also contrary to clean code. Clean code basically tells you keep it so simple that you don't need a complex IDE to navigate the ecosystem. I think that's also a very important quality in a lot of code bases. Because I'm sure you've seen this when there's like a hugely complex React component, and then you need to basically control-click through a bunch of different things, have 10 files open to just make a basic change. We had exactly the same problem with jQuery. We had exactly the same problem with more enterprise-y, Zend framework was notorious for this. It was very difficult to keep track of. Symfony recently had similar issues in the PHP ecosystem before it was simplified. There were just so much magic auto-wiring going on with the dependency injector that there was a lot of implicit knowledge that you'd have to carry with yourself depending on how things were named, in what folder they are, what is the prefix, what is the suffix of something. And you play this weird naming puzzle of if it's in the right folder, if it has the underscore in the right place, it'll create behavior because that's implicit in the framework, and your IDE just happens to know that.
Yeah, those magical things.
The magical is very difficult to work in an environment like that. And Clean Code also mentions it, but Clean Code mentions it to a wider degree in clean architecture. Is that those things should be infrastructural, should not ideally make it to the really important parts of your code that you then want to later test without having to express all of those magical rules. Okay.
Yeah,
Brent.
that was a lot.
Thanks.
Partition code, and you're leaping all over the place, and you don't know where anything is, and you can't keep anything in your head because you're constantly going here and you're constantly going there. But that is a smell. That's a symptom. That doesn't follow from the process of breaking things down into well-structured bits and giving them nice names. You can break things down into little bits and give them nice names without forcing that jumping around. And that's part of the discipline of clean code. You don't want to create those nests of leaping around.
Okay.
If you've looked in the book, you've seen that I like to order the functions in the
This
order
is
that they're
actually
called.
a
So
very
inside of a
quick
class,
interruption. This is actually the idea of coupling and cohesion as well. So if you have, for example, a larger functionality and you need to split it down in contextual parts. Don't split it up because of the sake of splitting them up, because otherwise then you have this clutteredness. But sometimes you want to have it removed because you reuse a specific function you import from somewhere else at this position. Because it sanitizes a string on a very specific way, you want to have that in the entire app always the same, then it is a different context and it's not part of the same file and context, and you get it from outside. But as long as it belongs to the actual core functionality of the current context, you shouldn't move it too far away from the function it is right now. Right? And if you move it outside of the file, move it very close to the file that you actually understand by not processing too much brain power, that is actually belonging together. This is, I showed you my...
It's also the idea behind
right?
clean architecture, vertical slice architecture, that things that change together frequently should be in the same folder, should be in very close by neighborhood as far as the project folder is concerned.
Yeah,
there's nothing worse than having one commit and it changes something in this folder, and then you go 2 levels up and five
this
folders.
Atomic file structure, which I don't like, where you have the atoms, the molecules,
controllers with
the
controllers,
organism,
controllers with controllers,
yourself,
models
my
with
God,
models.
So fucking but it's so spread around, right? That you don't understand what's going on. You jump between so many open folders, and you don't really understand how they belong together. And this is a big problem. Let's go ahead. We're a little bit over the half now.
I will say, well, here's the main function, and then below that are the ones that guy called, and below those are the ones that guy called, so that you can read down in a single scan and stop at the point where you say, oh, I think I understand everything. I don't need to read the rest.
I don't get that last part. That sounds very difficult. But
Difficult? Yes.
Yes. So I'm just like, man, I don't know if I could do that. I generally have a slightly different ordering, but I'll grant that to you. I put the most complicated usually at the bottom, the least complicated at the top. Because the least complicated are easy to kind of zip through, whereas the most complicated tends to be very meaty and slow rolling. Okay. I just wanted to get that out because I always have a hard time kind of reconciling how those work and how they work in principle. What it really sounds like to me is that what you're trying to say is that you need the program for 20 years, shoot yourself in the foot a lot of times, and then a lot of these things make more sense. Because, I mean, I'm not trying to put words in your mouth, but that's generally the advice I tend to give, which is that you have to shoot yourself in the foot 100 times before you realize how you've shot yourself in the foot, and then you don't shoot yourself in the foot as often.
The way I like to say it is that I like to be polite to the next person coming. Right? So any kind of code that forces someone to puzzle it out or leap around is rude. It's rude code. And I don't like my code to be rude. I want it to be polite.
Do you think that isn't some level of code you have to jump around, you have to puzzle it out? Because I'm not sure if names can always convey the context, because often the difficulty isn't, in some sense, the names. The naming is very hard. It's in the state change. And the state change can really only be discovered by not just what the function's name is, but by understanding why the state changes and how that affects the next said calls. Isn't there always going to be some level of that's why we both agree on the low comment thing. I think comments are largely useless.
Between accidental and essential complexity. There's an essential complexity you cannot get rid of. Then there's a bunch of accidental complexity the programmers add to it that they didn't have to. And my goal is to reduce the accidental complexity to as close to zero as you can get it.
Okay. I like to write a nice 100% accidental complexity line. It just feels good. Job security. All right. How about TDD? So
no.
I've gone back and forth on TDD. You're a very TDD fellow, right?
It is a discipline that I value.
Okay. Let me tell you my TDD success story. When I was a young fella, a long time ago, we had this app at a company called Web Filings, now known as Workiva, in which we had the original Flash app, in which people who are doing 10Ks and 10Qs, public quarterly reports, would do all their editing along with the spreadsheet, where you could link values and all that, update your spreadsheet, boom, it flows through all your documents. All your documents are now up to date with your spreadsheets. Pretty nice. And so you could do a comment on a spot, and then someone could review it, change all of that. And we also had an iPad. So I was in charge of the iPad. The iPad, you could zoom and do all that. That was some fun matrix equations for zooming and doing all that, because there was no zooming. This was just a web app and a canvas, and so we just we invented our own math there. And so we did all that. It was a lot of fun. But if you touch the screen, I need to be able to start a comment by you touching and dragging. So that's kind of like a fun, unique problem to kind of have. And the thing is that that has to line up with the original doc. So it's like, okay, well, I know a lot of this information. I know where every character starts because we did our own hand-rolled kerning, because kerning had to be identical to the Flash app as it is in the iPad app, which is an impossible problem, by the way. So you have to just invent your own kerning and write every single letter. And so that's what we did. We hand-rolled all of our own kerning. And so I knew where every letter started. I knew where everything about every page. And so therefore, I could write my own like test before I ever even started, because I'm like, we need a search algorithm that when I press this, it behaves this way. This goes in, this comes out. I know everything about the problem. It was a perfect, what I consider a perfect TDD problem. But I never had that again.
Okay.
My big problem that I see with TDD, or at least how I feel about it, is that I only know so much. And most of the time, I don't get the information that I need. It's like, hey, let's do something we've never done before. I don't even know what the enemy looks like yet. Why would I want to write a test first?
So,
yeah.
The way I do TDD is about one line at a time. I will write a test, and it's a very small test. It's maybe 1 line or 2 lines, and it will fail. And then I will write a line of production code to make it pass. This is so far below the idea of, gosh, I don't know what this code's going to do, because I clearly do know what it's going to do, that I can very easily write a test for that code. In essence, what I am doing is I am practicing double entry bookkeeping. For every line of code I write a complementary line of code that checks that I wrote the right line of code. Just the way accountants do with entering numbers into spreadsheets. Right? Well, okay, I'm going to enter a transaction over here. I better enter the complementary one over here and make sure the balance sheet is still 0. That's what test-driven development is. It's double entry bookkeeping. It is a way for me on a minute-by-minute basis to be sure that I have not done something so globally stupid that it'll cost me 3 hours of debugging time.
Well, I guess the follow-up is why not write? So this is generally how I do it. And I think you said you watched the stream for a little bit earlier. So you saw me where I developed the tower defense, the chat aggregator, and then after I like this structure, I kind of like what I have here. Then I go and I go, okay, I'm going to now test this to make sure it's correct. Like, right? I am not a fan of trying to run code to see if it's correct. In a sense that, like, I'm going to now fire up the whole program to make sure I've written this few lines correctly, because that is just like such a nightmare testing cycle that I always do reach for unit tests pretty quickly as a means to drive correctness and implementation, not as a means to develop the thing, right? So it's kind of like where the fundamental distraction comes from, is that if I were to start off with a test, it kind of almost feels like I've kind of already pigeonholed myself into what I want to do. When it's like, well, maybe I don't want to do it this way. Maybe I don't even know how I want to interface with it yet. And so do you ever find yourself writing some test code, realizing, okay, I can't even do it that way, then going back to your test code, then reformulating your test code, and then going back and reformulating this and kind of doing this back and forth on it?
Sure, that happens all the time.
So why not just start with your base implementation first?
There's another reason that I want.
I'm very curious, by the way. I'm not trying to like fight you on this. I'm super curious on this.
No, fine. Honest questions. I know we talked about honest questions. All right, so there's another reason that I want that test, or those suite of tests. I want to come up with a suite of tests that when it passes, I feel comfortable to deploy. I don't want to have to go through a long burn-ins period, where you get the system running for a month and everybody kind of stares at it and wonders if it's going to crash. I don't want to go through that. I don't want to go through a long manual QA process with a bunch of guys in India banging away on it. I don't want to go through that. I want to cut that off as much as I can. So I'll have a suite of tests that I can run. And if that suite of tests is covering almost every line of code in the system, I have a high degree of confidence that I can take that code and move it closer to deployment. I have worked on systems where that passing suite of tests was deployment. We would just deploy it right then. And if you're going to do that, you better have a real high degree of confidence in those tests. So because of that, I use this discipline to keep the number of tests high, and every line of code is somehow covered, more or less. Now, there's a whole bunch of exceptions to that. There's a whole bunch of places where that just doesn't work. A whole bunch. I shouldn't say a whole bunch. There's a number of places where that doesn't work. But where it does work, it's a discipline that I like to follow. It makes me feel very safe.
So I kind of have like a different view on testing.
So I've been watching the comments behind the screen, and one of the comments stood out to me because there was this comment of, yeah, but you can do that without TDD. Like you can write tests without TDD. And this is also one of the reasons I think this is why the video got recommended to us, because of this. So Michael, ThePrimeagen, doesn't TDD. And he's asking Uncle Bob about TDD. Right, so I can sense there's some resistance there. Like this didn't seem like an open-minded, honest question, because it's coming from a perspective of, should I be doing TDD? Am I wrong for not doing TDD? It's sort of coming from that place. And if it's wrong that I'm not doing TDD, why am I wrong? Is it possible that you're wrong? I see this kind of debate constantly on LinkedIn. And I don't find it super practical.
It is the difference between the standard programmer and the engineer. Period. There is this, it is just this one sentence. So the engineer is thinking ahead. So why I'm doing this? What is the outcome? And the developer, the standard programmer, is just going forward. Let's take a look what happens. So
yeah.
It is more like a playground thing. It is more like a
Yes.
prototyping process.
So-
but in production, and this is so embarrassing when you are sitting in front of your clients, right? You're presenting a piece of software, and suddenly the login is not working anymore when it was working. And then another function which was working before is not working anymore, right? And then I fix it quickly. And programmers feel like, hey, I can fix it quickly. Just tell me. No, the damage is already done. And this is so annoying to have. Really.
And I wanted to highlight this resistance, right? So they are fundamentally talking about two different ways of working, right? So plus there's chat, right? So chat says, yeah, but I can get high coverage. I can get tests without TDD. I can get, confidence without TDD. That's not the point. Uncle Bob said something very important, right? So what he's saying is that he doesn't want there to be a gap between I'm done coding and it is deployed to production confidently. Which means that if he's finished working on something, if he made it work, he wants to be able to get away from his desk, give this thing to his team without causing an incident. Now, if you're doing it without TDD, right? So and what's TDD in this case? It is having written the test double entry bookkeeping. He is done with both entries, and he's done the definitive entry last, and then he gave it to his team, and then it went to production. If he's only doing one side of the bookkeeping and he says, oh, it works, I'll write a test for it later. Or
that
now
was
I'm
testing
going to...
out, not testing. This is the difference. This is what I explain to developers very often. You try something out is not testing, right?
Yes.
So you have tried it on your machine
works.
in this context, in this exact order. And the next one is doing that in a different order, in a different environment, on a different app.
Manually testing whether your code works, that is not the same thing we do with TDD. The whole point with TDD is that we're not trying to guess or check whether our code works. TDD tells us whether our understanding of the abstraction was correct. TDD tells me I have no idea how to express this working correctly. So I will write up what I think is a very good approximation, and then I'll run it to see if it integrates correctly. But that is not the solution, because you can create a test bed that says it'll integrate like this, and when it is behaving like this, this will happen. And that's the thing we want to formally prove constantly, because if I then run the test and it works, I can now get away from my desk and get hit by a bus. And the code will still work. And the code will still provably be safe to deploy. Maybe it already was deployed while I got up from my desk and I went to the bathroom. Right? So the whole point is that Uncle Bob is focusing on engineering with a continuous delivery mindset. So when I'm done, I want to make sure that there's zero quality gaps between me being done and production.
Me being done is being done.
Yes. I want the done to mean done.
Way, right?
Yeah.
So it may be not the final iteration we do, but the iteration is done, and not half baked, tested by another person, and then fixed by you again after you're back from holidays. And this is something we all need to understand.
Yes. So the way ThePrimeagen explained, I'll try to make it first, and then I'll run it, see if it works, and then when that takes too much time, I will start writing tests for it. The problem is that it breaks up work into these phases of I'm definitely not done. I think I'm done. Now I'm test covering it. Oops, I created a few abstractions that are difficult to test cover. I need to redo things. And now I think I'm done. So it creates this phases of work where most of the progress is extremely low confidence. And what you're communicating is, I think I'm done. I think I'm done. I'm not done yet. It kind of works, but I'm not done. And then that's what you as a person end up communicating in your meetings, that's how you end up integrating with your team. Somebody asks you, hey, can you help me? Oh, no, I can't because I'm not done with what I'm working on. Whereas Uncle Bob is optimizing it for a work environment where he says, well, yeah, it's test covered. I can just revert back to the last green and I'll come help you. Right? Because you can throw away code. Like you just wrote 2 lines of code. Yeah, you can throw that away and go help that other person. Then you can restart the problem. Right? So it's this small incrementation that's so important about TDD. Not that it writes tests, not the test coverage. It is this ability to step away from coding and deploy whatever you had on your computer. Imagine every time you closed your laptop or you let go of your keyboard and you touched your phone because you got a phone call, all of your code got committed and sent to production. That's the environment we want to optimize towards. So that there isn't a lot of unfinished inventory sitting on your computer, waiting to be tested, waiting to be test covered, waiting to be fixed after test coverage shows that something is not okay, waiting to be refactored after you realize that it's actually very difficult to do, and then perpetuating this limbo of I'm kind of done, I'm not done, I think I'm done. Definition of done doesn't hold any meaning in that kind of environment, which is why TDD exists.
I would even argue that the tests, if you do test less development, are pretty shallow, I would say.
Yeah.
Sometimes I would even say, just do an end-to-end test and forget those tests because they are
Smoke test,
oftentimes they are so unmeaningful. You do a refactoring, they pass, and everything is broken, and you don't know why.
Because you don't get branch coverage, you just get line coverage.
The problem is that if you said that already, when you do TDD, you create a different architecture.
Imagine, Uncle Bob's analogy I really like. Imagine it's double entry bookkeeping. Imagine it's double entry bookkeeping, and you do 200 lines of code for which you don't do double entry. And then I tell you, well, it works, but now fix the books, please. You will hate having to go back and redo double entry bookkeeping for those 200 transactions. Also, you can't. If the code was integrated and some other developer is now starting to touch this code and starting to refactor this code, how will you guarantee that you will test cover it on time as it's being already used and manipulated possibly by somebody else? Well, the reason is, the answer is, you freeze it by keeping it in a feature branch locally to you so that you can then actually go back and fix it. But if that's the case, then you can't deploy it.
Merge, your test passes, but the code is broken.
Exactly. And then you isolate yourself and you have a long-lived feature branch. And that's how these problems start.
Yeah,
anyway,
but let's quickly, what is the psychology behind that? It's discipline. It is this missing engineering mindset that I actually don't think I need to get this done right now. Otherwise, I need to get this correct long term, right? Yeah. This is sounds small, but it's a huge difference in becoming a successful thing, because especially startups, they think they need to produce something extremely fast in order to get money to do it right later on, which is not possible anymore later on, even though this is a lie, actually. One of the biggest lies we have in the software industry. It is not possible to do it like that because you have other problems later then, and you need to fix those then instead of fixing, and no one will give you the budget for this. When you tell your stakeholders, hey, I need to do it again because that was
absolutely
actually not good.
That is the most ridiculous stakeholder conversation, and it's happened so often. Yeah. Most of my clients have them, which is why they call me. And it is embarrassing. They call me not because it has like huge business implications. They call me because it is embarrassing. It is the embarrassment that they don't know how to deal with. It is this I am ashamed that I said it works, and then on the last day it turned out we were late, and I had to create a reason, and I will have to have this annoying conversation with them again, and we appear as this black sheep department that nobody can rely on. That's the problem, right? That's the really hard leadership problem. That's why TDD exists. Kent Beck said himself, the whole point of TDD is anxiety management. It's supposed to give you confidence in your ability to deliver. Doesn't matter. that it gives you test coverage. It doesn't matter that it produces tests. For what I care, it doesn't even matter if you write code or you have ChatGPT generated. The whole point is that it gives you your team the confidence to say, this is safe to deploy to production, and I can step away and you can use it. And
There
it
was
won't
even the
blow up in
regret
your
that
face.
TDDs, actually the T, shouldn't be there because people are focusing too much on the testing aspect, not so on the architectural aspect, on the engineering aspects. But let's go because we have 20 minutes left.
Let's go.
Which is that I can only test the things I know about. Meaning that I actually have zero confidence every time all the tests pass green. I have zero confidence that there's not bugs in it, right? Like I'm just like, there's probably bugs. Like I just simply don't know what I don't know. And so even though all things are green, I'm highly confident I've screwed something up. And so that's kind of always been my general approach, which is this is probably the reason why I write my base implementation first and then come back with the test, because I already know what I know. And I'm not gonna catch anything unless if I've just programmed wrong and the things that I already know would break, they break. So why does it? So you say this 100-line, this 100, effectively you're broaching the subject of 100% code coverage, and I largely think 100% code coverage is a lie. I don't think there should be even a number on it. Why do you try to test every line? Try to test it.
So, first of all, I agree with you. I don't want a number on it. Any kind of number you put on that is a lie. But I think that you're always shooting asymptotically towards 100%. And I do that because I want that test suite that I can trust. I have lived in that world where the test suite was so good that I could trust it and deploy. And what that also allows is for me to fearlessly refactor. If I need to change the design of the system and I've got a suite of tests that I really trust, I can rip that system to shreds. I can tear it apart in a period of 2 or 3 hours, just making sure that the tests all continue to pass, change the design, rip things out, move things around, change this, change that. Tests all still pass, and I'm running those tests all the time to make sure they still pass. And I can have absolute control over the code. And I use the word absolute.
And the point isn't so much. Can you pause real quick?
That I can trust. So I have.
The point isn't so much that you can refactor. The point is that I can be done with something, deploy it, and then you can refactor. You can use my code and refactor it 30 minutes after I was done with it. Because I was done. I'm definitely done. I'm now working on something else. You can use it and refactor it, which is how TDD shops, engineering teams that have a culture of TDD refactor so much and so quickly and effortlessly. They just pick code and they just refactor it. I hate it when people commit code and then it's sitting on a branch and then it's waiting for a pull request and it's waiting for review. And they get upset. Oh, don't refactor that yet. It's still being reviewed. Don't review my PR. I'm still writing tests for it. I'm open the PR, but I'm not quite finished. I'm going to run some tests manually tomorrow and I'll finish it tomorrow. Right? So it's this fearlessly refactoring by other people now, 5 minutes after it's done. That's the whole point of continuous integration. It's about this idea of I'm not owning the feature. I'm not owning the module. I'm not the owner of this microservice. I committed code, you can change it. If I commit code now, you can change it in 5 minutes. And I won't be upset. And you won't break anything. And there isn't anything I'm doing in the background after I've committed it. When I've committed it, that's it. It's definitive. You can now change it. That's the whole point. The whole point is for the team to be extremely plastic and extremely agile about how they can use their code base. There is nothing worse than somebody saying, oh, I can't refactor this because I know Adrian has that branch open and I will cause a merge conflict for him for, end of week. That's what we're trying to avoid, because that's the dysfunction teams face when they don't do 3D, when they're not integrating continuously, when they're not doing trunk-based development, when they say they think they're done and it's not test covered and there's no formal proof of me checking whether your code works without actually running it manually. And it's that cognitive overload of having to learn too much stuff to test everything, to regain confidence, that makes such teams low-tier teams, low-performing teams. That require too much individual heroics rather than having a department-wide bar for quality. Okay, let's go. Almost there.
I've lived in the world, the other world. I have lived in the world where the suite of tests can't be trusted. Right? And there's no point in running them. It's like, okay, the test pass, so what? I know there's
exactly.
That's what I want to avoid. That's what I want to avoid. I don't want to live in that world. Now I'm working on a project right now where half the system has a suite of tests that I can trust, and half the system doesn't. And I have a nice division between those two parts. Happens to be the GUI, right, that I can't test properly, and then the rest of the processing code that I can. And I have one way of dealing with the code that's under test, and I have another way of dealing with the code that's not.
Okay, and so there's a lot of things that I want to talk about within all of that. There's just so many of them, right? All right, so I guess the first thing is that you did talk a lot about refactoring confidently. I guess that really dictates the type of test you're writing then, right? That must mean you don't test individual functions, you test only contracts. And is the assumption that when you refactor, the contract doesn't change?
Yes. So this is something you learn over a long period of time when you're doing test-driven development. You have to write your tests in such a way that they don't couple to the implementation. And that, first of all, that takes a very long time. And then once you do learn it takes a long time to learn. And then once you do learn it, you realize that you're only applying the exact same principles that you apply to all the code you've ever written before, right?
Yeah.
Because anytime you can touch a system in one place and it breaks in many, you've got a design problem. That's the definition of a design problem. Touch it here, it breaks in 10 other places over there. Well, that's also true of tests. If I touch it here and it breaks 10 or 20 tests, I've got a design problem.
Yeah.
It's actually one of the reasons why you should have synchronous reviews.
Can you pause it? Because I can't hear you.
And the answer is one.
Okay, this is one of those reasons why you should have synchronous reviews and talk about a ongoing architectural change. So
Or just pair program, yeah.
if you're an average developer, right, and you have the feeling that you don't really know how to structure this and you're doing right, just ask someone to join you in your current session and talk about that.
Yeah.
So this is so important to learn that as early as possible. And let's be honest now, most developers I have met so far don't know how to do it right. And I was
It's
the
a hard
majority of
skill.
my career the same. I was
And
just
the point
doing-
is, even the developers who know how to do it right won't get it right the first time.
exactly.
It is an iterative process, which is the whole point of why we're doing TDD, is that if I
TDD
write code and then I
refactoring, yeah.
change something and two things break, and like things break unexpectedly in two different places, it gives me immediate feedback that I can act upon and I can fix it so that in like 3-4 short increments, by the time I'm done with work today,
Yeah.
tomorrow the design will be awesome.
But we need to learn how to that we actually improve our own doing and the doing of the team with every time you get to a function to work on a function, you need to basically leave the function with an improvement. This is what you should do. This is the same with your life,
Boy
becoming
Scout
better
principle.
every day.
Yeah, it's like leave it 1%. Leave the code base consistently better, right? So yes, and I agree. Coupling to implementation. If I change something and it breaks 7 tests for no reason, that's a design problem. In clean architecture, hexagonal architecture, mocks, all of these things, they talk about design. If you test cover something and it breaks for no reason after you made the change, that is bad design. But clean architecture and clean code and hexagonal architecture, they make 0 sense, zero sense, if you don't think of your test design as you're designing your real system. They are the same system. Your production code plus your tests, that is the same system. If you're doing it like one of the people in the comments that says, oh, but you can do that without TDD. Yes, but then you're thinking about them as 2 separate systems. I'm going to write the code, and then at some later point, I'm going to write the tests.
This is an end-to-end test.
Well, no, but I can write the code first, and then before I commit this, before I push this, I will then separately write the tests.
It is an end-to-end test because so broken down to a unit. Because what you actually do is you only test the rough input and the rough output, but nothing in between anymore. So you can't rely on changes, what happens in between. For example, we had a function where we needed to filter out of a complex data structure where people are actually present, basically presence days, time slots and stuff like that.
A mix of aggregation, presence,
This
live
is actually
data,
quite hard to implement and
very
hard
difficult.
to test, right?
Yeah,
and
very
you
difficult.
can't just say, I expect that. So this is helpful, of course, to know that it's still working. But if you need some feedback, what exactly is not working? So if you have 10 different cases defined in your test and one is failing, you have a pretty precise area where something is wrong right now.
Yeah.
But if you have just one iteration and somehow it fails, and you don't even know under which circumstances, yeah, great. So it is, of course, better to have that kind of test than none. But let's be honest now, this has nothing to do with engineering. This is just, it's a smoke test.
I mean, it is engineering, it is a smoke test, but it's also a very low performing engineering practice. You know, when you're talking about engineering culture, it's just coding, it's just programming. It is treating delivering the code as a separate problem from delivering the test, as a separate problem to deploying. It is the anathema of DevOps. It is this idea that my responsibility is to write the code, not to deliver the product to the customer. Right? It is continuous service to my customer. That is the point of agile, not writing the code. Treating test writing and designing tests as a separate problem from designing a system, that is the core. It's the integration of those two worlds that TDD solves.
Yeah.
Robert mentioned linked a post here by Addy. Addy is an engineering leader working on the Google Chrome team, and he has some tips for
Just
effective
type
software.
it into your browsers, no problem.
Yeah, it's this link. If you're on the LinkedIn, it's this link. And there's a lot of things I disagree with, right? Because it is making this assumption that code reviews are necessary, that code reviews are important, that code reviews are a high quality activity, and that code reviews are implicitly asynchronous. So his advice is optimizing a broken process for flow. Right? So the process is broken. Two people have to overinvest to fix something. So it's optimizing each person's responsibility. Here are some examples. As an author, you should review your code yourself first, break up large change lists, narrowly scope changes, minimize lag between rounds of review. Don't forget the docs, discuss things upfront. As a reviewer, check what is required, check that it's well designed, check that it's readable, check this, no complexity.
You don't know in that moment if it's well designed or not, if you haven't discussed it. So better call it, make it a code discussion than a code review.
Exactly. My point is, all of this activity is pointless because it's coming too late in the pipeline. This is flow optimizing, right? So you should be optimizing your company, your organization, your engineering team for collaboration.
Yeah.
If you cannot optimize for collaboration, you should mentor them, optimize for mentoring. If you cannot optimize for mentoring, then everybody splits up and works alone, and then you optimize for flow. You optimize for how effective am I when I'm alone and being left alone. And then when you're no longer able to do that, then you're optimizing for hands-off, and you're optimizing for management. You're optimizing for complexity, cognitive load,
but you will start to lie to yourself and to your team because you give something into review with the big expectation and promise that you will fix and change it, and the review you won't. You get it done because your business person is yelling at you when it's on when they get it finally. Then you release it and you go to the next problem on the next page, which will be unfinished as well. So you basically start to do this. What is Boeing at the moment doing? So they have so many problems right now because they started to save and not doing engineering anymore, but just producing as fast as possible. They start to behave like a modern software development company, and that's bad. We should rethink and think about that. We are actually software engineers and need to get things done the right way. Otherwise, we don't fulfill our credo. And I hope you as an engineer, if you call yourself like that, you have a credo and you know what an engineer actually is. Please, you are not an engineer because you have done or read a book and created a website. You are not an engineer. Sorry to say that. An engineer is, in Germany, for example, something very protected. And you need to get to this point and earn you the point that you actually be able to work in a mix between an application and a scientific way in order to make sure you're doing is not harming anyone or anything or the business in the future.
Exactly.
So hand on your heart, is it like that in your doing? And I bet, and if you say yes, but have never thought about that, you lie to yourself. Sorry, you lied.
There might be
I
some
lied to
resistance
myself for so many years, but I paid for that myself because I'm an entrepreneur. I learned it the very hard way so that even my family was feeling this. So I'm very honest about that these days, and I don't have any problems to tell anyone because most developers lie to themselves. And we need to learn about that.
You just deliver code for money, and that's
Yeah.
the wrong approach about it, right? So if you're delivering code for money, you're not being realistic about questioning practices like continuous delivery, trunk-based development, or TDD, because you're coming toward this conversation from the wrong perspective, which is exactly the resistance that I mentioned earlier between how differently they approached the conversation and what they optimized for.
Good. We are nearly not through, right?
Nearly not through. Let's go.
If you can get there. It's not always easy to get there. But if you can get there, it should be one. How many modules should you have to modify when there's a requirements change? One. If you can get there. That's kind of the goal of design. You want to focus change on individual modules so that when a change occurs, one module is affected. If you can pull that off. And it's not easy to pull that off.
But that's only assuming that every module has one dependency, right? You could have many things depend on one thing.
Yeah.
Quickly. It is easy. You just need to have the willingness to learn that. So go ahead.
And to have many files and then to
that's a
refactor them.
problem. And if a module has
Yeah, go ahead. Sorry.
And to have many files and refactor them, right? Because you will end up creating a lot of small files, a lot of small modules, and then it will start looking like a mess. And it is then your responsibility to organize them in such a way, to refactor them. That's what refactoring means. So that it doesn't look like a mess anymore. If I have my kitchen cutlery all over the kitchen, it'll be a mess.
Yeah.
But I can put all of my cutlery into the drawer. The amount of cutlery in the kitchen is still the same, but it is now hidden behind the drawer. And when I pull out the drawer, it only has the cutlery. That's cohesion. Right? So the whole point of splitting things up into small pieces isn't to maintain that state. Splitting up into small pieces is a mess. But that's only decoupling. That's why I hate when people say, "Oh, the single responsibility principle forces me to create many small things." Yes, but then you have to bundle it back together. Then you have to bundle it back together.
That's a very high-level idea, not explained in detail.
Yeah.
Let's go ahead.
Let's go.
as many outgoing dependencies, that's a problem. And you can't eliminate them all, but you can control that. You can minimize that and get some kind of discipline around the number of dependencies between modules. I wrote another book about that called Clean Architecture.
But don't you? But that if you do that, you also introduce natural abstraction that doesn't technically need to be there, because now you're just abstracting to specific interfaces. You're just putting a man in the middle.
I am putting a barrier across an axis of change. So yes, the interfaces that you would put in there, the abstractions that you would put in there, are not strictly necessary for the behavior of the system, but they vastly increase the ability to modify.
Very important point.
They keep
what PrimeageN just said. It's again coming from this perspective of, oh, I have an abstraction that doesn't need to be there. Yes, the abstraction doesn't need to be there for the production system. The abstraction needs to be there in order for the team to be able to quickly test it. The abstraction is there so that the team can test it very quickly. It's not there for the production system. It's when people ask me, why are we creating an interface for our repositories? Can't I just, it's so much easier for just there to not be an abstraction between me and the database. Well, yeah, you're right. The production system doesn't require it. But the team requires it if they want to deploy continuously, test continuously, and test with isolated developer tests without having to spin up an integration system, right? So in the context of the code doesn't need it to work, yes, it doesn't make sense. Clean architecture doesn't make sense. Hexagonal architecture doesn't make sense. But if you want a software engineering team that's building a product that is being continuously delivered and it is automatically tested, then it is necessary. And there is no alternative for it.
And especially when you say component-driven approaches, and you haven't have a ports and adapter pattern or hexagonal, basically the same.
Or providers in like React equivalent,
yeah,
right?
Then you don't have a component-driven system. That's actually the case. Then you have a highly integrated, massively coupled system, which is working somehow, but you don't know
linear,
exactly
inheritance-based, limited composability, very difficult to isolate.
Exactly. So it is extremely important to understand those patterns and why you should have them. And it's not only testing. There's several more reasons. Maybe we should have a dedicated session about that at some point.
Yeah, and
easy to make a change here without.
Sorry, and this is easy to test in your code base. For you, live audience, if you pick your system apart, your classes, your functions, if there's only one way to put it together, then you have this problem. That's why it's difficult to test, because there's only one way to put it together, right? So you have no substitutability, you have no substitutability, you have no composability, and you have no distinction, destructuring, decomposition of behavior, right? So the entire system does one large complicated task when assembled in exactly one way, and that is the only thing you can test. And then that'll create an incentive for you to gravitate towards end-to-end and smoke testing and regression testing. And for the QA department to do that on the observability and operations side, rather than the engineering department doing that as their process and actually preventing defects by planning, rather than fixing the symptoms after the defects have already been introduced.
We need to hurry because I don't have much time anymore.
Affecting something here.
Okay, sorry.
All right. I tend not to. I'm very pro anti-abstraction. I'm not sure. I probably should just say anti-abstraction. I try to very minimally abstract my code when possible. All right. So that
we began this by saying, I don't put abstractions in unless the need is there. But the need is there if I've got a change here and it's affecting a bunch of stuff over there. Then I'll put an abstraction.
I don't know. I think sometimes requirement changes are big enough to just warrant that. Right? Like if someone changes your fundamental data type, a lot of things require that data type. It's just by its very nature must change. The only way you can do that is if you can predict the future. And I have proven to myself I am a shitty future predictor.
And that's true.
Yeah, because then I just have to make the same number of changes. It's just propagated through 10 places that eventually get to the tips. Now you just have one changes 8 times as opposed to one change that is 8 oopsie daisies.
You're always going to get bit by that. We always get bit by that. It doesn't mean that you can't mitigate it. And by the way, also, when you get bit by that, you have the opportunity then to make sure you don't get bit by it again. Because the most likely thing to change is the thing that's been changing already. So if you can catch it early because somebody made a change and you can put in a protection for that change, then when they change that thing again, and they will, you'll have a protection built in.
Maybe. I'll give you a maybe on that one. I'm going to give you a maybe. I'll give you 50-50.
Okay, so much resistance.
I'll take that.
So I'm going to go back to a little bit of testing. When it comes to testing, and you try, your goal, as you say, is asymptotically reaching 100%. Why?
Yeah.
Why does it matter that you cover every line of code?
Because I want a test suite that I can trust.
And but not all code is all code worth testing?
No.
All code is worth testing. Any error, any code that is in error can cause catastrophic.
I would say all behavior is worth
all
testing.
Code is worth testing, but not all code is worth testing directly.
Yeah,
I don't mind indirect tests.
For
example, I don't write tests for my getters and setters.
I like that.
That's stupid, right? But I do write tests for the functions that call the getters and setters.
Yeah, that's a point as well. For example,
Right, so
when especially in higher order components in React, for example, you have it very often that this is not really a unit. This is highly integrated oftentimes, where you aggregate a lot of things, where you even have things.
If I'm just prop drilling, the aspect of prop drilling is not worth testing because
therefore you have in the end the higher integration tests, right? Which covers those kind of things. Is the database data correctly interpreted in the UI, and can you click on the next button? Stuff like that. This is integration test. So it is actually not necessary. So you need to understand what to test, and especially when you go down into helper functions, into hooks, into those kind of things where you really have algorithms which need to make the right decision in the right
and have
way.
behaviors and have behaviors beyond how they are implemented.
Exactly. That's good.
I like the distinction he made. He said at first all code is worth testing, and then he quickly corrected himself in saying not all code is worth testing directly. I like that he corrected himself, right? So it's not worth writing a test for each permutation of implementation, but it's important that the double entry bookkeeping is still working without me expressing explicitly how it's implemented. That's very valuable.
I actually, when I do testing, I do basically, for example, in React, I actually, when I make a change, I write the asserts for the unit tests and for the end-to-end tests. That's actually an interesting point. I test the end-to-end tests actually later because they take too much time for that. But it is actually a good thing to see if your prediction was actually what you were willing to see in the end on the screen, and then you have it done already, just with one or two minor corrections, maybe. Just wanted to say that this is actually
you're keeping it concrete.
Exactly, concrete.
I can't get the implementation right first try, I test it.
Okay.
And so that leaves some level of code always untested. Because I have
got the implementation right the first time.
Because some things are really easy. Sum and array.
Say that again. Some things are really easy.
Some things are really easy. Sum and array. Like in JavaScript, you have to sum an array, right?
Would you write a test for summing an array? I wouldn't.
I wouldn't write one either, right? And so I have kind of like I have a general rule of thumb, which is that if I'm doing something that is trivial in a function, I just don't test it.
So, yeah, Kent Beck used to say, only test the things that could possibly break.
Yeah, that's one reason why I do like errors as values languages, is because they kind of force you to think about the places in which things break. Uncomfortably so, but nonetheless they do. That's why I've always been a very sus of the JVM, is because it's kind of just like, you don't have to handle it if you don't want to. And it's just like, well, maybe we do want to handle it. Or at least think about it. It should be inconvenient when there's an error.
Okay.
You don't think so?
I'm not a big fan of multiple return types. Like Go does that. I don't like the comma separated.
I am.
I think that's
going on me.
So I prefer to throw exceptions in languages that allow exceptions to be thrown.
Yeah, but then you have a whole control flow problem then, because now you have to you necessarily skip a whole bunch of lines, and you may even skip out of your function, right? Like state becomes very unknown if you don't have every line that has an error considers the error.
So I mean that's also true when you return error codes. If you return an error code from the middle of a function, you may not know the state of how that function left things.
By the necessity you do, because you actually chose, okay, I got an error, I will now have to return from this error. Like you've made that choice at that point.
Yes, you have. And if I throw an exception, I've chosen to throw the exception at that point.
But you don't know where and what. Yeah, I know, but that's the problem, is that if you caught it 3 functions up, you now have many layers. Well, come on. So you've worked in places with at least 3 functions up. It's like if you want to JavaScript,
I throw go-tos everywhere. It doesn't necessarily mean it's a good idea. But I like the exception model myself because I don't like to throw long distances. I throw up to the next function. So it's very much like an error code, except that it's taught in a different way.
So
Go has a great
solution. Just like 2 ways.
Go, the language, is a great solution to that. You are forced to only throw short distance, right? So you return an error, and then the calling function has to deal with it always.
Just JavaScript when the promises.
Well, in JavaScript you can still propagate errors. You can throw exceptions and not catch them. Fetch is notoriously error prone. Cross-domain security issues.
Yeah, you can do that, but it is actually work to do that, and I think most people don't do that.
Yeah, like in JavaScript, the idea was that the exceptions will be made compatible with bubbling it up as an event up the DOM tree, and then on the highest level in the browser, at certain point, it will pop up, if nothing else, to the user, which is why Internet Explorer 5 had a alert box with every uncaught exception in JavaScript, which was extremely annoying.
Yeah,
but that was the proper way of you are forced to handle the exception. If the developer doesn't, the user will.
But not the user
but that is the wrong way about it. It's the wrong way about it. At the same time, not a huge fan of the Go syntax. There's this if return, if assign thing, assign error, and error not. It's very wordy. I wish they had improved on the syntax and not made that C-like.
In 10 years, we only have JavaScript anymore, where they finally removed Node, and we have a decent execution time. Then there's no reason anymore for anything else.
Fair.
Let's go.
Ways to return values, because that's what it sounds like. If you do a try catch every single time, by the necessity, you have multiple return values. You just have multiple return channels.
Okay, I'm happy with that.
Okay. Yeah. Okay. Hey, that's fine. Hey, look at that common ground. All right. Who would have guessed? All right. Well, I guess I don't think we'll probably ever see eye to eye on unit testing fully or test-driven development. No, I mean, like I said, I've used it once where I really understood the problem, and it was absolutely fantastic for sure. But what do you prefer when it comes to testing? Do you drive more towards integration level? Like, where do you choose your level? Is higher better, or is lower better, or is there any rule that you can say?
So I'll just go back to Kent Beck's statement. I will test anything that could possibly break. I like to pose my tests as abstract tests the wrong word, general tests against a family of functions rather than a test against every individual function. I like indirect testing. I want to make sure every line is covered, but the tests themselves are written at a slightly higher level, but not so high that they're called integration tests.
Yeah,
they're still unit tests. They're just testing a slightly larger unit than a single function.
Okay.
Indirect
Integration
behavioral
testing?
unit tests.
Yes, absolutely.
How much
Unit
effort?
tests.
That's actually a good point. Just when you have the molecule level, so you have multiple atoms in a molecule, and you have written the molecule in a way that it integrates the atoms too much, then you have testing problems. And this is actually a good sign that you have done something wrong. If you can test a molecule because it's a cohesive unit, and you can still test it without an integration, then you have done it right. So just
and the sign that you cannot test it is because you need to control one of its inflowing dependencies, and there is no easy abstraction to do that without also messing with the behavior. A database is a great example for that, right? So there is behavior in how the query plan is formed, or how the query is transforming a string into data, or what the timing of that is. And if you don't have an easy abstraction for that, that is speaking the language of your domain, just clean architecture, hexagonal architecture, then you might be forced to write a mock that is controlling the invariant in a very clumsy way, which will make your test more brittle, not less. So that's a design problem.
Okay, but I really need to hurry now. Sorry.
It depends on the complexity and the size of the system. Unit tests are myopic. When you're writing unit tests, you're thinking of one thing. When you're doing integration testing, you're thinking about a number of things. You've got a bunch of balls you're juggling in the air. So they can be very useful, but they should not be testing business rules. Integration tests should be testing integration. They should be testing the choreography and the flow of data through the units, as opposed to individual business rules. It's a waste when you do individual business rules in integration tests.
They're slow.
Okay, I guess I'm slightly confused by that. Isn't the output of any integration test a series of business rules? Aren't you testing like a summation of business rules?
So my goal in an integration test is not to make sure
Not
that all the
directly.
business rules work. I may have to test a business rule in order to test the data flows. But if the data flows work in an integration test, I'm not going to go through every one of the business rules that use those same data flows.
Okay.
I've got unit tests for that.
Okay, so you just do more like, does the system continue to operate? I asked for a piece of data, it did return this type out, we're good enough? Is that kind of what you're trying to say?
Yeah, it's a little more detailed than that. I want to know that the processes got started properly, the data flow channels got open properly, that the right kind of data went across them. So I might be putting in special little widgets to test those kinds of things. I might stick in some extra fixture code that will look at the flows of data across those points. Integration tests are very technical. So that's the kind of thing a system architect does. They're trying to plumb out the way the whole system functions.
You remember when we go through the app with the web, I integrated widgets which gave me more information, and I could assert those informations as well without implementing too much new code. That was kind of interesting approach as well, and that helped me actually a lot. Just a tip: it is a little bit.
It's like booting up a car in a workshop in maintenance mode with the dashboard open.
This is maintenance mode. Just make sure that maintenance mode is not production mode.
It's a full integration test. The engine will be running. It's not a simulation. The engine will be running, but the car needs to know that it's in a garage so that it'll expose more diagnostics.
Exactly, and optimize the output of the car, right? So
and possibly to be nullable is
right now.
To be aware that it's not in a production system and that it needs to not make any like real transactions, or it needs to not, trigger the airbag because it's not actually in flight. It's not actually moving on a road. It shouldn't check for GPS for movement to not overheat, etc., etc.
Okay.
Let's go.
I see that a lot in integration tests, like a bunch of golden files being used. Like I start up our system, it goes off and it talks to the DB, it does all these things, and then I expect this exact like shape of output. How do you feel about that kind of the golden? I guess they call them golden testing.
Yeah, it's a move of desperation. You don't have enough insight into the system, so the only thing you can look at is the output, and you don't know what's going on
snapshot
inside.
testing.
And so, okay, well, geez, it seemed to print the report fine. I guess the system's okay. Well,
Not good.
If it's a complicated system, that's
Not
not
good
a
to
very
snapshot on
comforting
integration.
approach.
Why not?
Because you're only testing a very small subset of the behaviors that you're trying to test. If you've got 2 or 3 golden standards out there and you run the tests and all the golden standards work, you have not hit the conditions that the golden standards didn't cover. And you don't even know what those conditions are.
Yeah.
So you get a false sense of security. Now, if that's all you got, Okay, that's all you got. But I would not start a system and with the goal of testing it with golden standards. Golden standards are the least effective way of keeping a system under control, in my opinion. Other than just not testing at all.
I mean, can't you make that exact same argument for every smaller set of tests? Because in some sense, a unit test is really a snapshot test. Just in the snapshot just happens to be really tiny.
Well, yes, the snapshot's tiny. The number of moving parts is innumerable. And then you made the point earlier, if you've only got 8 bits, you only got 256 possibilities, and you can completely flesh that out. Now, I can't completely flesh out the behavior of a system, but I can look at an individual function or an individual small family of functions and be relatively certain that the behavior of those functions is well covered. Am I 100% certain? No. Am I relatively certain to a high degree? Yes. Golden standard doesn't give you that, because the golden standard is way too far out at the user interface. There's too much stuff going on in there, from my point of view, and in a complicated system.
Okay. Well, unfortunately, I do have to go. As someone said in chat, my wife is going to be angry at me. I may be 15 minutes late. I do appreciate having you on here and talk about these things. The goal again today was just to have it. So
I think they are in the wrap up now.
Yeah, we can wrap up too.
Exactly. So there we are again. So it actually was an interesting video. This is the first time I watched it in its entirety, and I don't know exactly why. I had it differently in my remembrance when I was watching the first time, but actually Uncle Bob was most of the time right. I think he corrected himself during the stream from some extreme opinions to
oversimplified,
more average thing where you can say, okay, we need to find good compromises there in order to get everything right, but TDD is the preferred way and the recommended way in his opinion to go, and that's actually very fair, and this is how I see it as well. I'm not a hardliner as well. I'm more making sure that everyone can use it. It does make sense. You don't need to, you really need to only test things which are necessary. So, but the point is, and this is a psychological point I was coming to, you should not fall to your own resistance, which means that don't lie to yourself by telling you don't need to test it then. And this is the reason I think why those books, why people are then being a little bit more hardliner to get the people to actually do that. In order to, because resistance is there.
Brian is like that. Dave Farley is like that. Like they're a little bit more hardline than they need to be, just to get it across that no, you're just being resistant to the core idea, which is continuous delivery, continuous integration, and continuous deployment. We don't actually care about the test writing.
And what I wanted to add as a second point, which I think is very important, is that TDD is only very well working when you have the circumstances around the team in a good state as well. So what I mean by that is, if you are in constantly like your boss is coming in, giving you changing requirements on the very same thing you just finished yesterday evening, and it's 90% of the code changes, then I understand that people say, I don't want to write tests anymore. I don't have the time. I don't get things done anymore. I'm stressed. I just want to die here, right?
And TDD doesn't cover that, but extreme programming does. I'm an extreme programmer for that reason,
but
right? So
this is what I mean by this is actually you need to make sure that it is the same as the garden anecdote again. So you need to make sure that the environment is actually prepared for what you want to do. And if you want to have that kind of quality, as we said at the beginning, make sure the business stakeholders, the product managers, getting closer to the engineering and making that actually a problem of themselves, what's going on in the production department, right? And make it less of a department, but as one big team. So basically dev biz ops, if you like. And if you have that, then suddenly, if you can show and prove to everyone in the business how much of a difference this will make, they start to think a little bit ahead as well, and start to debounce again to make sure that the requirements they get So the ideas they have when they have a shower in the evening don't suddenly become your new requirement for the next day. You need to change everything.
Correct.
And this is something you need to communicate, because business people think it is possible and okay to do it like that.
You can do TDD and you can iterate, but then if your boss comes in tomorrow changing his mind constantly, there's an issue, right? So one of the requirements for agility, one of the requirements for extreme programming is the bill of rights of the engineers and of the customer. And one of the rules is that software that is being produced needs to be demonstrably valuable. So if I produce something, we as a team need to be able to demonstrate that this was valuable to the customer, right? So if you're always changing your mind, you're demonstrating a lack of facility to quantify how valuable software engineering is for you, which is why you're course correcting constantly. But that means that you should stop engineering, not that you should stop doing TDD and speed up going the wrong direction. Planning XP, extreme programming, even the collaborative aspects of extreme programming cover this. Agile is a bit too simple. It requires a little bit more holistic implementation. DSDM covers this. It covers it with the Moscow principle of, if it's urgent and you're changing your mind, it'll be difficult to demonstrate value. But if it's causing harm, then we can do it. Then there is a reason. There's an objective there. But if you're just doing it because we are lacking confidence as business holders, because we are lacking vision as stakeholders, because our entrepreneur is unsure of the product efficacy, you need to talk more to your customers. You need to get your engineers closer to the customers and figure the heck out what makes the software valuable. If you don't know that, TDD is not the problem.
I would correct that, because I'm a big fan. This is one of my biggest topics. You don't need to get the developers solely closer to business. You need to get the business and development closer to the actual problem, because they are both a distant away from the actual problem where they need to be in order to get that done. This is important to understand. This is not a one-way change. This is not the developers don't understand business. It is the business don't understand developers. But they try to be a tech-driven company. So this is not possible in that moment. Right?
Yeah, you can't have product and engineering be divorced and try to figure out like a flow optimized way of dealing with that.
Get away from the idea of department. Just have that single sentence on mind and think about that for some minutes and some days, and you will figure it out for yourself. It is actually quite easy.
Awesome.
Right?
Didn't you say you have to go?
Yeah. Yeah, actually I have to go. So
cool episode. I'm glad we did this. It's great to be streaming again. It's so great to be streaming with you again. I really missed it. And my voice is finally back. We're all healthy.
I think it was some form of new wave and we all not recognizing it. We were all sick at the same time. Here in Europe, I had the feeling. But yeah, next Wednesday, we're starting off
Brian Finster.
With Brian Finster. Quite a similar topic, actually, just more focused on the front
more
end.
UI focused, yeah.
And this history of... wait a second, I quickly posted. This was my last post. I was not very active this week. I had a viral last week. That was cool. The first time I had a video viral.
Nice.
That was kind of nice. To see a 1 minute clip being seen, I think 7,000 times. That was quite cool, but I don't find
your short video production quality and video setup, it's really taking off. I really enjoy like those headmask videos on Substack and the shorts you're filming for LinkedIn. Pretty cool.
There it is on LinkedIn. We will have it on YouTube this evening as well. I will set it up after the show. So we have 60 attendees already. Brian Finster is with us. And we're talking about the history, very shortly about the history of front end, how it developed. So early days, vanilla JavaScript into the Explorer 5, going over prototype JS, jQuery, then Bootstrap, then
I love jQuery nostalgia.
First time we saw a totally new pattern. React made this pattern then very popular until today.
Ribbits.js was actually the first one.
Yeah, but Angular is the first one really known about that. And then we have those things today, but still we have the problem that the front end is the place where most developers start today to become developers, but they are not developers yet. And there is one of those big things going on right now where everyone is blaming each other. Hey, you use React. Hey, you use Tailwind. We should use vanilla. No, you can't use vanilla. We should. So we will talk about this argument as well. We will talk about how to apply good practices, like TDD, continuous delivery, DevOps. DevOps is actually something very important for front-end development. No one really noticed that. It is always connected to back-end and infrastructure somehow. But we need to get along with them. And talking a little bit maybe about, in a small sections, about Jamstacks and how they are something in between those worlds. Let's say some good ideas with bad behavior from the past. So like
Jamstacks are like Web 2.0 with proper continuous delivery, with proper DevOps practices.
Yeah, exactly. Very fast to begin with, very bad to end with, and that's something we can talk about as well, because Jamstacks are actually when you start an application with a focus on the front end, and the back end is just.
It's what all the kids are learning. Everybody's doing.
Next.js is basically a Jamstack by itself, right?
Yes.
And you can do it without. So we for example use Next.js not as a Jamstack. We use it as a client creating app framework. So we have a separated service backend. But now let's do it. Let's do it on next week.
We have the entirety of next Wednesday for that.
Yeah, we have 16 CEST summertime, 4:00 p.m. You see it in the post. I just
I'll announce the timings for Thursday. It'll probably be in this time slot because kindergarten. So I do have to go now to pick up the kiddos. Yeah, great stream.
Yeah. So I can't take it away.
There we go.
Yeah. See you next week. Then let's just go.
Enjoy the weekend. Get some rest.
Goodbye, everyone.
See you next week. I'm gonna put on some elevator music and enjoy. See you soon.
See you. Bye-bye.
Ciao.